Okay, cool. So, hi, I'm Dennis, or also CG Tinker. And at first, I want to thank you to set up this event and also thank Mike a lot that he invited me to take part at this presentation. And I actually developed Blend AR Mocap, an augmented reality motion tracking toolset for Blender with Google's Media. It features hand, pose, and face detection, so it focuses on character animation. And actually, I wanted to tell you the story behind it, how I actually came up with the idea to develop it. Basically, all started with Blender Track. I developed Blender Track in my thesis. It's a mobile app for Android and iOS and features camera motion tracking and face tracking. And well, this is basically an earlier version. And here you can see me just placing some reference objects with a mobile device, moving around, tracking the AR scene, and then transferring it to Blender with just a couple of mouse clicks. And this was basically the main result. And the face tracking was basically just a face mesh. So after my thesis, I decided, hey, I want to transfer the face tracking data to Richify Rig. And when doing so, I received a couple of comments where they mentioned Meetup, like I should look into it for full body mocap, or did I check it out? And I was like, what's Meetup? And I looked into it and I saw, hey, it has face tracking, hand tracking, pose tracking, and I looked at their GIFs. And I was totally amazed by the quality and the responsiveness of the media. And so I thought, hey, I'm really stoked and want to learn more about Meetup. At first, I checked out if there's actually already something in Blender, if anyone transferred the results to Blender. But as I didn't find anything, I decided to make a bridge of the data to Blender. And on the right side, you see my timeline, basically, how I've developed. And at first, I focused on transferring just the data to empty. So here's basically the result of the hands. And I thought, hey, this looks freaking amazing. So I just parented some bones on it. And well, I saw there are some issues like weird stretching, some weird angles. So it isn't that easy to just parent bones or something. And when we look at the pose detection, it also looks awesome, especially the upper body movements look very natural. Sadly, the legs are floating a bit, so I just focused on the upper body and added different drivers and constraints which can drive a Richify rig. And the face tracking part is quite funny, actually. I thought this would be really, really easy because I did basically the same with Blender Track. But Meetup doesn't have a local space. It only has points in global space. So the entire process was really, really different. So I ended up using Measure It a lot. Measure It helps me to figure out which data I'm actually using to map results and for my mathematical issues. And yeah, I really appreciate the Measure It add-on. And here you can see me just doing a short face capture and transferring it directly. And this is part of the beta. And yeah, well, as I have shown those results in my Discord, people were urged to try it. So I figured, okay, I have to set up a beta version. And yeah, after some cross-platform beta testing and a lot of bug fixing, I was ready to release the beta. And yeah, it was a lot of fun. It was great. And of course, I had to bug fix again, because if you release something, you always have to bug fix a lot because users will always find different issues. And yeah, that's why I basically started to improve my architecture again. And here, just a short look at it. Basically, it's divided in 3 sections. One is the detection, the other is the processing of the data and the creation of custom data. And this data is getting mapped in collections in Blender. And this data from the collections then can be transferred to the Richify rig. I try to make all the processes as easy as possible. And by now I'm trying to improve the tracking results and also the transfer results. And I'm happy to announce that probably in this month or early next month, I'm ready to release a new version, which won't have the beta state anymore. And yeah, you can get the add-ons, Blend our mocap and Blend our track on my Gumroad for free. I would happy over every donation, and it would be great if you join my Discord. I will post links in the channel in some seconds. And if you want to support my development, you can also become a Patreon. And yeah, that's about it. Thanks a lot. And I will give it to Mike, who will show you how to use Blend AR mocap with an actual character.
Thanks, Dennis. And Mike, by the way, guys, provide the links that you want to post to us in Discord, and we'll relay those to the YouTube chat, because I think it blocks URLs for everybody but us. So send them to us. We'll share them with others.
I will send them.
Thank you.
Thanks.
All right, Mike, take it away.
Yeah, I tried to post on the YouTube channel, so the addresses are there, but they're not links. So sorry about that. I wasn't aware. Okay, so let's go over this fantastic add-on and show how you can create motion capture with your webcam. It's really amazing to be able to do that, and to be able to do that without all kinds of motion capture suits, gloves, or head cams, or any other kind of hardware besides a webcam. I hope I'm sharing the screen now. Is everybody seeing that, I hope? Yeah, okay.
Yep.
Okay, so first, let's download the add-on from the links that we have provided. So in order to do that, you need to go and download the zip file and put it on a location on your computer. Once you've done that, you need to open up Blender in administration mode. In order to do that in Windows, you need to right mouse click on the Blender icon and then pick Run as Administrator right there. Once Blender is open, you need to go to Preferences to load the add-on and go to the add-ons page and scroll up to Install, and install the zip file from the location on your computer. Once that's loaded into the add-ons, you need to scroll to where development is. Development Blend AR mocap appears, and you need to check that box to load in the add-on, and then go to the left of the arrow where the arrow is and open up the add-on and press Install Dependencies to install the dependencies that are necessary for the add-on to run properly. Once they're installed, this button will be grayed out, as you see here. So that means all the dependencies are installed. Okay, so as Dennis mentioned earlier, one of the basics of this add-on utilizes MediaPipe, and MediaPipe lets you capture the points that are necessary for the visualization of full body, as you see here. So that detects the motion of the body, the arms, legs, and the torso just from a camera. And that's what MediaPipe can do. That's pretty amazing, right? You can also capture the facial rotation, sorry, not the rotations. You can also detect the points for the head as it turns, and also the expressions. So Media Pipe is detecting what's happening just from a camera. It also detects the hand movements. As you can see here, it detects those points for the hands as they're moving. Okay, that's really fantastic, especially when all you need is a camera to detect those points. But there's never been a connection between the Media Pipe's Google research software and a computer animation program until now. Now, Dennis Su has created this add-on that is a bridge between the Media Pipe detection and the computer animation software in Blender. And so now we're going to demo how the actual software works in Blender. Now, once you've downloaded the add-on, you should see the add-on inside of Blender in Layout. And if you go to the right, you'll see the button for Blender AR mocap. So when you click on that, you'll open up the menu for the add-on, which is comprised of the detection part and the transfer part of the add-on. Okay, so let's start detecting. In order to do that, we're going to detect the body motion. At this point, this version detects the upper body and the arms. And we're going to set the key step to 8, which is a key for every 8 frames in our detection. We're going to set the target to pose, and we're going to, in order to start the webcam, we're going to press the start detection button. Now, I have to stop my video because I'm using the webcam for the stream, but the software also uses the webcam in order to capture motion. So the key steps are used for keying the animation, and once you set up the transfer once, the key steps also can overwrite the animation if you want to re-record your animation. And the key steps also start at where the start of your playback is, down in the lower part of Blender. So let's get going. So let's start detection for the pose. And I'm going to just create some real basic animation here, but you'll be able to see the process in real time, which is pretty amazing. And since I've got a little bit of a slower laptop, the pop-up for the web cam takes a couple extra seconds, but you'll see it in a moment. And we'll be able to create motion capture just with your webcam, which is truly amazing. And here we see the detection of my arms and my shoulders. And I'm just going to create some real basic movement so you can see how this works. But we're able to detect all this movement and fairly accurately. In order to stop the webcam, you press with the right mouse button and start detection. And now we're going to go to the lower part of the software and click on drivers. CGT pose appears, and you want to set your armature to your rig. I've already set up my character with the correct weighting for this setup. And then all I need to do is click on Start Transfer. Okay, so the transfer is done. We can go to the start of the transfer, and I'll scroll through it so you can see that we have captured the movement that I had. Pretty amazing, right? Okay, that's cool. Now, let's go to the hand portion and capture the movement of the hands. We're going to set the key step to 4 because we can have less gross motion and more detail with the hands and the head. And again, we're going to start detection. And this time, the webcam will recognize the hands, and we'll be able to capture the motion of the hands. And as you can see, as I'm moving, my hands, the points on my hands are being detected. And the software that Dennis has created converts that to rotations in the rig so you can create motion capture animation, right? Okay, again, to stop the webcam, you press with the right mouse button. And this time, we're going to go to CGT hands, which has now appeared. And for the armature, set the rig and click Start Transfer. Now, in this version, which is beta, the hands look a little bit weird. So I figured out a way we could correct that. We can pick the rig, go to pose mode, and then set the influence to 0 for the hands. That corrects the rotations. And now we can use the widgets to rotate the hands to a more reasonable rotation.
Hey, Mike, we
Yes.
appear to have lost your desktop share.
Our what?
We appear to have lost your desktop share from Zoom. Could you reshare your desktop?
Sorry, yeah.
There we go.
Sorry about
that. No, that's okay. We can see it now. Thank you.
How much did you miss?
Just like the last maybe minute to minute and a half.
Did you see the hand capture?
I'm not entirely sure because I was sorry, I was multitasking, but maybe you could just repeat the last maybe 120 seconds.
Yeah, it's just you're at the influences basically. We were seeing that you switched to pose mode and then it stopped.
Oh, okay. Sorry about that. All right. So now I'm trying to rotate the hands so they are more reasonable. So as you can see, I kind of rotate a little bit so it's a little bit more realistic. So now if I scroll through, the animation of the hands is there too. Okay, that's pretty cool. You know, we've got it almost there. Now we can go back to object mode and record the head. So in order to do that, I'm going to leave the key steps of 4, set the target for face, and again, start detection. Oops. I've already set up my character, even with hair and clothing, you know, it's pretty set up. And now I'm going to record my head movements and also some of my mouth movements, so you'll be able to see that. So here we have the recording of the head and the mouth. And this is going to develop even more as Dennis, you know, develops the add-on more. So we'll have more recording happening of the details. But right now, we can stop the detection and take a look at our results. So we need to set the driver to now face, and again, start the transfer. Okay, you can see the head move. That means it's finished recording. And now we can see, if we go back to the first frame where it started recording, you can see the hands, the head, and the body are moving in tandem. Cool, right? So now we can, hopefully I won't stop my share. We can go to the render mode with Eevee and have a more realistic representation of my character with textures. And I'm using 3.0.1 because I want to have RenderMan working on my system. So RenderMan works with 3.0.1. And now we can see that we have all the detail in Eevee for this animation. Without further ado, I'm going to render this, and while I'm rendering, if there's any questions, you could ask them, and hopefully we'll be able to try and answer them for you. And what I do in order to render is set up my textures, and I can even set up my lighting. And then I click on the viewport render animation, which is a pretty fast way to preview your work. So that's pretty much it for me. I'll show you the result of the render after it's rendered, which should be in about 1 minute. And we could take questions now if anybody has anything. We could.
Yeah, so hey, this is Sterling. So we do have a question in the chat from Ice Driver. Says, just wondering, how do you get a video in that isn't from the camera?
Yeah, well, I think this will be supported in the future to just import videos. I've seen people using OBS to fake a webcam stream and then basically use a video as stream via OBS, but that isn't supported yet.
Gotcha. Okay, thanks for that.
Yeah, and I think that the way it's set up now, I'm running on a laptop, like I mentioned earlier. You can take your laptop anywhere. So if you want to record somebody else. You just take it to where they are and record them on your webcam. I mean, I think this is pretty convenient for doing motion capture, more convenient than I've seen. And I think it's more efficient to be able to do it live um, with a live subject in front of a webcam, because then you can redo your takes and re-record right there if you see something funny happening. I mean, the tests that I've been doing have been fairly short, but I'm looking forward to really recording long form and really have long performances for this add-on and see how that works, because there's really no limit to it. And I think it's really convenient. You can always plug in a webcam with a wire to lengthen your area, or go to another part of the location where you're at in order to make it convenient for the mocap.
Hey, Mike and Dennis, we have another question in the YouTube chat from David Sykes. He says, or they say, can you capture the motion of the body, hands, and face all in one shot or recording, or do you have to do it in 3 separate shots or recordings?
Currently it's separated because using the webcam doesn't allow to do all at once. Basically it works, but it's just too slow. It won't be convenient anymore because you would have just 1 frame per second. This is the future step with video animation. I have it in the back of my mind. I want to do it. It's just not implemented yet, and probably won't be in the release version, but we'll see.
Excellent. All right, thanks for that. All right, Mike, Dennis, that's it for the questions so far. So,
am I still screen sharing? Can you?
You are, yeah. We have 3 minutes until the next presenter. So, if there's anything else you want to cover.
Yeah. So let me show you the finished render, so you can see the results. Pretty amazing. I mean, I'm just blown away. I don't know about anybody else, but I have been pretty amazed. But it's still rendering. Sorry about that. I thought it was done. We got like 8 more frames. But if I encourage everybody to really try it out. I mean, to be able to do mocap with pretty much no cost in order to create the motion capture, I just don't know any other solutions that are this viable. And there's really, Dennis has made this, so there's really no limit to the length of your animation, of your capture, which is another feature that, I just don't see out there for, the amount of investment that you're going to, put into this. So, okay, so let's open this up. Also using the GameRig plugin for Rigify, which lets you transfer your rig to a game engine pretty efficiently. So I'd encourage people to do that. So I'm going to run this at half speed so it looks a little bit more realistic. So here we have the motion capture. I mean, if you look at the detail of the motion, you can see like the neck's moving correctly, the arms are moving good. I don't have full rigging for all the different parts yet because I still have to work on the weighting of my character. But I mean, come on. Have you guys seen stuff, the results that are this amazing? I haven't.
It is very cool.
Yeah. So this gives you a pretty good overview of how you can create motion capture with your webcam, and how you can, supplement your pipeline into creating animation through motion capture, and adding that to your projects at a pretty fast pace. We've created about what do we have here? About 5-6 seconds of animation in just a couple minutes.
That's great. That's great. Yeah, thanks, Mike. Really appreciate the demo. And Dennis, it looks like an amazing tool. I'm guessing there's going to be a lot of World Blenderhead Meetup folks all testing your tool over the next 24, 48 hours. So thanks for coming to show it. And yeah, great session, guys. We really appreciate it. And looking forward to hearing how it develops. Maybe you could join us next year and show us the progress.
Cool. Thanks.
All right. Cheers, everybody. So we have Jason Van Gupsters on the phone and on the line. And Jason joined us last year at World Blender Meetup Day 2021 and made some big announcements about Orange Turbine. And yeah, we're looking forward to what he has to say. Jason, introduce yourself, talk about what you're going to speak on, and then take it away. You have the next 30 minutes.
Woo! Hope I'm hearable. I am good. Of course, I've got to follow that. Ah. That's all right. That's all right. We're good. Hi, everyone. I'm Jason. I'm going to do the screen sharing thing because I did this all slide style. And I'm covering a lot. So forgive me if I speak fast. You can play it back later at half speed.
All right. We can see your slide.
All right. So I should be all slidey, happy, screeny stuff going on here. I certainly hope, at least. So, yeah, this I'm doing a talk. It's last year I talked about getting yourself using larger workflows for even if you're an individual artist. And then at the end of that, I said, oh, by the way, we're starting this Orange Turbine thing. And so it's been a year. So Orange Turbine, year one was helping Blender be part of the conversation, or what have we been up to in the last year? And so that's what I'm talking about. And so I'm going to give you a quick introduction for those of you who don't know me. I've been kicking around the Blender community for quite some time. I am the lead for Orange Turbine, which is part of CG Cookie. We're a consulting firm for getting Blender better integrated into larger workflows and studio pipelines and those sort of things. I'm also the author of Blender for Dummies. I'm lead moderator at Blender Artist. I started Right Click Select. And I have a podcast that I haven't aired any episodes in like a year, so I should probably take that off the thing. But that's me. But let's talk about what Orange Turbine is for a quick second here. So as I said, it's a consulting firm specializing in the integration of Blender into small and large scale production pipelines. So we're talking about Blender deployment. We're talking about pipeline integration. We're talking about automation, add-on development, that kind of fun thing. And of course, training, because part of the CG Cookie family, training is kind of one of the things that's built into what we do. Now, one of the things as we're doing this, as we've gone over this in the last year, we discovered something pretty interesting. It's kind of one of those things, it's a little embarrassing now to mention that since we've been doing this for a year, we should have sort of realized this at the beginning of this, but tool makers need just as much or more help integrating Blender as studios do. When I talk about tool makers, I'm talking about people who make applications that also have to talk to Blender. So even Autodesk stuff, Adobe stuff, smaller applications like things like Sync Sketch and these other really cool things, or things for project management, they all need to be able to interface and interact with Blender, either by taking renders out or working with actual blend files or getting some sort of data exported. And that's not an easy thing. That's a challenging thing. And when you get into a studio environment, you expect these things to talk to each other. And so a lot of the onus is not just on the studio to fit it into the pipeline. It's for the tool makers to say, all right, I need to make this easier for you, because people who are doing their shows or whatever they're producing, they actually need they want to focus on that are important to doing that rather than making things talk together nicely. So that's what we've discovered. And so what do we actually do? So I want to hit a couple highlights because they're kind of fun and really exciting for the way I think, at least. So one of them is a lot of IO, right? We're talking about pipelines. We're talking about getting things working into larger workflows and those sort of things. And one of the biggest things is, how do you get Blender data to talk to other applications? And because, I mean, there aren't a lot of other applications that will just randomly read a blend file, even though it's open and there's kind of a means of doing that. It's just not currently done. Oh, and I'm called Wiggly Toes. Oh, I lost my mouse here. Hold on. There it goes. Okay. So in terms of a lot of I/O, we worked a bit with GLTF and FBX animation. So one of the things is GLTF is an open source format. It's very cool, but the way that Blender exports stuff from it with the exporter is maybe some things are a little bit alien for other people. So if you have multiple characters being animated, unless you know that it packs all of your animations using the NLE, then you don't think the exporter is complete. By the way, it packs it with the NLE, so you can get a bunch of different animations from multiple characters by packing them down in the NLE, and that's a really great way of doing that. It's still I'm still have an open discussion on to how to order those, because right now it just does it in alphabetical order. I would really prefer it to be whatever order I put it in the NLE. It shouldn't be a big change to the add-on. That might be a patch that we'll be doing sometime down the road. FBX, of course, is the other sort of data interchange elephant in the room. Blender has FBX support, but as we all know, it's sort of clean room implementation, right? We can't use the official Autodesk SDK because it's a bit antagonistic to open source in general. So the Blender implementation, the Blender FBX support is necessarily incomplete. That said, there is a really cool add-on on the Blender market. It's called the Better FBX importer exporter, and that one has the developer that does a really clever thing in terms of being able to use the SDK. He actually built his own interim file format that he converts everything to, which is very clever. But he also was missing a few gaps, and over a bit of discussion, he was able to implement IK support, very basic IK support for FBX importing from Maya through FBX to Blender, which was super cool. But also, we did I did a little bit of add-on on our own. We made a little small fun one, the export to blend add-on for those workflows where you have a character that you've built and it's already in a scene, but you want to use that character as a linked asset in another scene. This is what export to blend does, and had a lot of conversation with the pipeline development folks about how that might work and getting it to integrate well with the asset manager and those sorts of things. And there's a couple updates I need to do to it, but we had a lot of fun making that, and it's been very useful as far as I can tell. Another fun thing that we did was the Eat Sheep project. The Eat Sheep project, and it's really hard to say Eat Sheep very quickly multiple times, so I'm gonna stumble it and say different words. I'm sure I am. But the Eat Sheep project is an in-house open movie project that CG Cookie is actually doing, and seeing as how Orange Turbine is helping with working with pipelines and developing pipelines and getting Blender to be part of that. Eat Sheep is using Blender for as a DCC, but it's actually rendering out through Unreal. And so trying to do the conversation between those two applications and make them work out, that's where Orange Turbine could, basically we were eating our own dog food in terms of CG Cookie. So they asked me to figure out what their production pipeline should look like, where you do stuff that's Blender related, where do you do stuff that's Unreal related, how do you get things to cooperate and communicate with one another, and those sorts of things. And it turned out to be a lot of interesting things, because you're not necessarily going to use the same flow for different parts of it. If you want to do your scene assembly in Unreal, then you're not necessarily using linked assets or things in Blender the way you would do it if you're doing it all in Blender. Or for instance, if you're doing your character animation, again, FBX with deformations and fixed shaped keys and IK and FK switching. That doesn't necessarily translate very nicely when you try and go through FBX to go back to Unreal. So maybe you want to use a limbic for your hero characters. And so that was a lot of exploration, and that project is still going on. So you can keep following it at each sheet. They're doing some really they're still in pre-production with the storyboards, but the storyboards are all being done in grease pencil, and they're phenomenal. Paul Kajeji's been doing a phenomenal job with that. So eatsheep.com is where that project is, and we're continuing to sort of provide help. But since the establishing of the way, setting up their standards and their policies and their procedures, and then they adhere to it as their production sees fit, which is the way things always work. So that's been a fun project that we've been a part of. We also got to work with Adobe, and that was super cool and super unexpected and kind of interesting. So Adobe learns Blender. So they're interested in 3D, right? In fact, they do 3D with the Substance line of products, and even they're getting more into AR and VR and these sorts of things. But they have their 3D digital content creation products, and they actually also have add-ons for Blender, right? They have the Mixamo add-on and they have the Substance add-on for Blender that works fairly well. They even also have very talented 3D artists on staff. However, the challenge is most of the artists that are on staff at Adobe are Maya users. Most Adobe customers are Blender users. And so they need to be able to understand Blender enough to support it for their customers. And that's their interest in having Blender knowing more about Blender, because they don't know Blender by default. They need to learn Blender because that's what their customers are using. So what we did, our solution was we provided training for them to help them bridge that gap. And there's a series of 3 different workshops, 2 of them being beginner level and 1 of them being really high level, or more digging into the Python API and what you can do for developing add-ons and making general pipelines better, and seeing where they can, what things are going to be beneficial for making their applications again work well with Blender. So if they've already got a couple of add-ons, they're likely maybe to make more. It's hard to tell, but these sorts of things are really exciting to see them. And really, I'll have to stop for a second and say something really cool happened while in that. One of the things that I've always said when talking about the advantages of not just Blender in general, but open source software, was that with Blender and open source software, 9 times out of 10, if I have a problem, I can actually find a developer that's doing that stuff. I can talk to them and say, this is the problem I'm running into, and they can tell me that I'm doing it wrong and show me how to do it right, or tell me how to do it right. Or they say, oh yeah, that's the problem. It's a bug. I'm going to fix it. And then they get it fixed for the next release. And you really can't normally do that. You can't do that with proprietary software. Most of the time, you don't even know who developers are. Funny thing is, some of the people that were in these workshops we're giving were actually developers. And so when tasked with showing how to do interfacing between, say, their beta project, Arrow, which is an AR project, product, I was pointing out how some of the GTLF imports weren't working, and the way it was importing was a little bit weird. And yeah, they emailed me back a few weeks later and told me that they fixed that. So sometimes they do listen to feedback. And so that was a very, very cool thing to see. People are very proud of their products, and I was really excited to see that when you have feedback and constructive feedback on how a certain thing is working, you can get people who are proud of their work to do that, even if they happen to be using proprietary work or proprietary software. So that was very cool. Now here's another fun one that we've been working on, and they're actually really having fun. It's a company called Elio Labs. And so one of the things, again, we found that a lot of the people who need our help they can be smaller studios. They can be also not necessarily in the entertainment industry at all. They're people who are using Blender for all sorts of cool and interesting stuff. We have tool makers who are doing, all their stuff to interface with all kinds of customers. You do have like Eat Sheep style production going on there, but you also have things like Elio Labs. And what they're doing is they're actually making a medical product. It's a cosmetics and medical product. And it's a really cool thing that basically what it's done, it's a type of mask you put on to reduce wrinkles, and I guess you sleep in it, and it'll do that sort of thing for you. It's an interesting bit of technology, and really it's a cool product. It's cool technology. It uses 3D scanning for custom fitting of things. So because you want to have something that's going to be form fitting, so it uses 3D scanning for that. It uses 3D printing to make those custom products for the people who are doing it, and they power that all with Blender. The thing is that each mask has to be manually customized. So you have a single artist sitting down every time. So you get the scan data of the face, you have a single artist sitting down. And while you can have a workflow and you can build yourself templates and you can do these sort of things to make the process less arduous, you have to have somebody who is actually skilled in Blender to sit down and model it and make whatever sort of modifications have to be made to custom fit the face. And that's time consuming. And if you're looking at selling a lot of these custom masks, having one person who's an expert doing that is not cost effective and will probably burn that one person out. And on top of that, it gets expensive if you have to have more of those people. So really you want to try to automate that. And that's one of the things that we brought to the table. We built a custom wizard add-on to automate their workflow. So you have the face scan, which comes in as data to import to Blender, and basically there's a wizard interface here. Click here on the face to mark where the eyes and the nose and some landmarks are there. Get some general positioning, show where the eyes are going to be detailed. Oh, okay, so the liner's made, and then you can adjust that to make sure that there's a custom fit, and you don't have to be manipulating geometry directly. It's just the things that pardon me, that a not necessarily a Blender expert could do, just somebody who understands how to point and click and follow directions. And then ultimately you end up with the mask like that because that's generated by this add-on. And then they can take that to print the liner, print the mask, and then ship it and have it and sent to their customers and having a good old time. I think that product is supposed to be launching this month. So the add-on is there to help them meet all the requests of people who want this particular thing. And so that was a really really fun bit of automation, because you don't really see Blender itself is not necessarily built or designed with the idea of wizards in mind, right? It's not like pardon, it's not like click this button, click this button, click this button, and I have a thing, right? That's typically you're assuming Blender is going to be your content creation thing, and you're going to sort of make whatever you want, and you're not going to go with sort of this hand-holding wizard thing. But because of the fantastic work of John Denning, who's part of CG Cookie and part of all of the stuff we're doing, and if anybody at the last Blender conference, the last in-person Blender conference, John gave a very cool talk about Cookie Cutter, which is an API that he's developed that works with the Blender API that you can make custom interfaces. And this is basically done doing that. And it's very, very cool. So what's next for the turbine? So tools and solutions, right? That's really the name of the game for what we're doing. We've learned that in addition to studios, large, small, entertainment, whatever industry you want to talk about, any sort of CG studio is going to need tools and solutions. And some of those things do take form in what we've been doing on the consulting side. And so, yeah, we originally thought that Orange Turbine was exclusively a consulting firm, that our job was to help studios and toolmakers make their jobs faster and easier and better. So we weren't doing things for them necessarily. We were just helping them do their stuff better. The stuff with Elio Labs is a great example of that. But it's not just that. People need solutions, and we can actually build them, right? Even if we're helping, it's not necessarily helpful to say, well, in order to do that, you just set this up, set that up, and do that, or you hire a developer to make this for you. Sometimes that's the effort of trying to find the right developer that has the expertise that you need to do what you want, and then explain to them exactly what you need. You might not have the expertise and understanding of that about Blender in general or CG in general. So that's the sort of thing that Orange Turbine is looking at doing more custom tools for specific pipelines, but also standalone products that can help everybody who's not, necessarily in one of those custom pipelines. In addition to that, there's moments when you do add-ons where you need to make additions and improvements to Blender itself, and hopefully shepherd those that's not a word, shepherd those patches through the patch review process and those sorts of things. And so, I mean, my dumbest example of this, because I've done this before and I did it a while back, but the dumbest example I have for it, which is one of my favorites, was I wrote a joke add-on, and I still actually have to update it. The render music add-on. I don't know if anybody's ever played with it, but the render music add-on basically plays elevator music when you render. And then when your render's done, it stops playing elevator music. In fact, I think it also does a gong when it was done. The problem with that is that in order to have that add-on work, the Python API had to be patched to add event handlers for render start, render stop, and I think render cancel. So there were those three. Those didn't exist. So I made a really small patch. That's my one small patch contribution to Blender. I made one more, but that was a patch I made for Blender for a goofy add-on. But it also that patch helps with render automation. That helps with render farms. It actually has a lot of other widespread uses. But being able to explain the functionality of having that patch in there and sort of shepherd it along through the development process is one of the things that Orange Turbine has experience doing. And even if it was for a goofy patch, we can do it for things that are more serious as well. As we continue making more tools and run into things, we're like, oh, we need to actually have Blender modified to support some of these things. And so relative to that, you're gonna have to stay tuned. Stay tuned as in like not this talk, but like maybe next week. There's some cool stuff coming down the pipe for Orange Turbine in terms of announcements. And yes, this is in fact a tease. But speaking of tools and solutions, and I actually almost have enough time to actually talk about this. It's fun. So I'm going to introduce something that I'm calling Swiffle, mostly because I couldn't think of a faster name. So Swiffle's the name of an add-on that we're working on for making SWF interface with Grease Pencil. It's an importer and exporter for SWF. Yes, really, SWF. And it is still 2022. And yes, I know that Flash is dead as far as the web is concerned, but in 2D animation, people are still using Adobe Animate. People are using Adobe Animate and TubeMoon, right? Those are your two primary things. But interchange file formats, it's pretty wide open. There's not a whole lot there. SVG, you could, the specification says, yeah, there's animation here, but the support for SVG animation is a little lackluster. So and then of course, still not also the animation, SVG animation isn't necessarily supported within Blender itself either. So SVG is what's used for interchange. And the spec is, I'll say, mostly open. You can download it from the Adobe website and go through it. It's a little bit out of date for things, but for a lot of the uses that you're going to use as a linear animation studio doing 2D work, not necessarily anything with like games or ActionScript or anything like that, but if you're just using it to do traditional style hand-drawn animation, SWF is actually not a horrible format for it. And Grease Pencil is something we want to be part of that conversation. So, this is where I do a little demo. All right, so let's make sure I have all of this work here. The first thing I'm going to say is the other challenge with doing any development for SWF is that you can't just go to a web browser and play it anymore, because none of the web browsers support it, because it's a security nightmare, and we all know that. But that still makes it difficult to find decent test files or even run those test files when you have them, especially if you happen to be running Linux like I do. Fortunately, there is a nice little Rust application called Ruffle. Let me switch my called Ruffle. So I'll just real quickly, here's their website. It's kind of bare bones, but it's written in Rust, and it's a Flash player, and it's actually really cool. So I can go in, and I have an example file here that. All right, so this is audio running in the background, but okay, so that is an SWF file, and that was graciously, I have permission to use that from Stephen Brooks, who wrote Digital Animate CC. So he's an animator, uses Adobe Animate to do his work, and he has a bunch of example files that come with his book, which are these little small test files are great for testing. These little example files he uses for lessons are great for testing for import. And so what I've been able to do is start Blender this way. If you go in and do the 2D animation thing, and you say File, Import, Flash Animate SWF. And I find that file, gives it a,
and Jason, if you have any additional time, we do have a couple of questions and comments, but
perfect.
Finish your demo.
So this is it's imported. It's in Blender. You can see it. It's using grease pencil object with a whole mess of layers for each of the layers that were used when he made that. Materials are imported. Now I do have a few Z fighting issues and figure out where holes are, because SWF has some really weird ways, and kind of clever but very weird ways in how it handles edges. But just to sort of prove the point, so it's playing. You want to hear the audio, but the audio is there too. I was able to import the audio, and we have the ability here. And again, I'm missing some of the lines in his fingers. The geometry is all there. It's just not in front. And so, and you get all your onion skins and all of these things, and the frames are all available to adjust and edit and animate. And then next step is also the exporter, so I can get that back out to SWF, and you can put that into any other program. There are some things here that do require a bit of thought. The way that grease pencil currently handles texture and gradient coordinates, or texture coordinates, which is how it also applies texture fills and gradient fills, is wonky. It is really, really bizarre. And so you'll have other examples like import. Oh, wait, hold on. I need another small fixing here. Don't save. Would be, so in the original version of this file, there's a gradient there, and there's a gradient for his nose, and these textures are smaller. But the way that the coordinates are currently done in grease pencil are, they're hard to make predictable results. So that's one of the patches where we're going to look to try and pull into Blender itself to support having kind of same coordinate systems for textures and gradients that we can actually import and predictably place them. So that's one of the things we're having a lot of fun doing. But of course, it's still early days. The biggest thing is finding nice self-contained files to do it. Stephen Brooks's files are phenomenal, but for a few features that are in SWF, I need to find some that very specifically look for some stuff. Exporter still not functional, and bugs, so many bugs. That said, if you want early access to this and feel like you can help by either testing or looking at some slightly bug-riddled code, I would love for you to do that. And you can contact me very easily by doing that. And I have time for questions too. Whew.
Nice one. Yeah, you fit it into 30 minutes. I'm impressed.
Yeah.
So we have a couple of questions. So like Cybran Sugal is asking, do you think USD would replace GLTF, FBX, and Alembic at some point?
There's a lot of talk about USD, and a lot of people who are doing more. Actually, there was a studio just within the last year who has a very, very cool USD utility, and they got it working with Blender, and they open sourced it. And I can't remember the name of it, but it's a Russian studio, and they're doing some really, really cool work with USD. And there's a lot that can be done there. The difficulty with USD, especially as it relates to Blender, is that USD tends to, from what I can tell, it tends to sort of dictate the overall structure. And so if to make Blender fully USD compatible, you'd actually have to change quite a bit of the fundamentals within Blender to do it. I think you can get a lot done with it, but just like with everything else we do with Blender, there are some moments where what Blender can do is more or different enough from whatever an open source standard is, that it does make it difficult to to fully adhere to those standards. When, say, for instance, when we were first talking about Open Subdiv didn't support non-manifold meshes where Blender Subdiv did. And so there's going to be a lot of that conversation to bridge that gap.
Excellent. All right. Thanks for that. And so Cybert also mentions those render start stop handlers are super useful. He's used them in trainings as well, making lots of noise in an otherwise quiet room. So it helps lift the atmosphere of the poor, quiet, shy students. So
Perfect.
there you go. Making renders more fun. All right. And all right, excellent. And then I think that's about it for the questions. So awesome presentation, Jason. Really exciting stuff. Yeah. Anything else you want to say before we hand it over to Mike Penn?
No, I think that Mike's going to show some awesome stuff because he always does. So I want to step in his way there. But yeah, seriously, if anybody wants to talk to me about SWF stuff, I would love to hear from you, because the more I can get help on it, the faster I can get it out.
Okay, sounds great. Why don't you hang out in the YouTube chat if you're around, and maybe you can answer any questions that come up. So like Cybert says, Brecht had a rough guesstimate. It would take about 10 years to really adjust Blender's internal structure to make it possible to have USD as a first-class citizen. It sounds like a heavy lift to me. But excellent. All right, thanks, Jason. I really appreciate you joining. I hope to hear from you again next year and see how things are progressing with Orange Turbine.
Absolutely. Take care.
All right, excellent. All right, Mike, you on the line?
Yeah, I'm here.
All right, thanks for joining. So everybody, we have Mike Penn from the Pixelry. He's going to be presenting on an animation project that he did for AMD. And I'll let Mike, do you want to maybe do the intro and I guess introduce yourself and then introduce your session, and I can
Sure.
stream the video.
Sure. So yeah, as Sterling said, I'm Mike Penn. I'm based in Vancouver, and apart from my day job, I sort of run a small animation studio with working with a few artists around the world, and we do animation project here and there, and yeah. So the one that I'll be presenting today is an animation that we did in the later half of last year. And it's something we're quite proud of. It was done in Blender 3, sort of Blender 3.0 beta, and it was done for AMD as really a way to validate, how the new AMD card would work on Blender 3.0 with cycles, because they're using a new backend now. So instead of the OpenCL, now it's using the HIP, the HIP backend for rendering, for interfacing with the device hardwares. So yeah, really exciting project. It was done with over the course of, I think, 2 to 3 months. And yeah, so it was done mostly with 2 artists, and then someone from AMD side kind of overseeing the project. So yeah, the talk itself is pre-recorded because I have a little one at home, so I just don't want too many interruptions. Yeah, Sterling, whenever you're ready, you can roll the video, and then I'll be here to answer any questions after the fact.
Okay, fantastic. I'm playing now.
Welcome, everyone. My name's Mike. Today, I will be sharing an animation project that we did for AMD of this beautiful Mercedes car. And I'll sort of take you through the process of what we did, some of the tips and tricks that we learned along the way, and just show you the fantastic new features of Blender 3.0. So without further ado, I'll play the video. So, hope you like that. This is the team behind the work that you just saw. The voice you're hearing is me, Mike. I'm the art director. I'm responsible for sort of the lighting, the animation, and sort of the general look and feel. The modeling and the texturing and all that sort of detail work and the vehicle is done by Piero, who's our sort of lead artist at the Pixelary. And we are fortunate enough to have worked with Alexander from AMD, who brought the project to us and also provided creative input on basically, how they envision everything will look. So this is the team that worked on the project, and the reason why this came to be is there are a few reasons, right? So AMD, as we know, they make graphics card among other things, and they also have a partnership with Mercedes AMG F1 team. And in fact, you'll see a logo of AMD on the car as well. So basically, what they wanted to do is kind of to, showcase that kind of cross promotion by building an animation for their team. And the reason why we are doing this specifically now is for Blender 3.0. And what's new in Blender 3.0 is the new AMD HIP backend. So if you don't know what that is, I'll just kind of quickly go over that. HIP, this is what it stands for, Heterogeneous Computing Interface for Portability. But ultimately, what that means for for us as artists is that it replaces the old OpenCL. So in Blender 2.9, you have your CPU rendering, your CUDA and then optics rendering, and then you have OpenCL, right? In Blender 3, OpenCL is gone. It's been replaced by HIP. And HIP is enabled for basically all of the Radeon 5000 and above video cards, okay, on Windows. Currently, they're only for Windows. It's just a more modern interface. I don't know the specific details, but I was told that basically it allows the developers to work sort of on a unified code base without having to kind of cater to OpenCL specifically. So the idea is that it just whatever you write, whatever that works on CPU and GPU, it will work sort of on Radeon cards as well. Just to make this chart a little more complete, in Blender 3.1, I believe we also added Metal, which is for macOS. So Metal is enabled on their M1 devices as well as Radeon devices as well. So that's HIP in a nutshell. This project actually is a continuation of many different iterations. So almost a year ago, we started working on the what's called the W12 car. So that's the current year, the 2021 Mercedes F1 car. And we made a whole bunch of images, as you can see here. And these images are done with AMD's ProRender render engine. So it was built in Blender, but instead of rendering cycles, it was rendered with ProRender. Now, ProRender is neat because it's very similar to cycles in how it handles material and lights. So we were able to basically just build the Blender scene more or less as normal, right, using Blender materials, and flip to the ProRender render engine and more or less get a one-to-one representation. Of course, there's going to be differences, and we were able to resolve those. But these images that you're seeing now, they are rendered with ProRender, but again, built in Blender 2.9 something. So once we have the car, right, which was the model, the geometry of the car was provided to us, but we worked on the materials quite a bit, and we had to add a lot of textures, and we redid some of the details like the wheels, and we add a lot of little bits and pieces here and there, and I'll get more into that later. So again, these are all done in ProRender. Here, actually, you can see that we have also done quite a few in different aspect ratios because apart from sort of wallpaper, social media is a big one. So we've done some square ones for Instagram. We've done some portrait ones for cell phone. Once we got the asset, the first step is really to make sure that everything's nicely organized. So here's the car. I have to be pretty careful showing the model. So, everything that we've done here, I'm just showing you screenshots. We're not going to dive into the actual Blender file today. Basically, what we've done in order to make this scene work for a lot of the other stuff we want to do is we built sort of a master car file, right? So this file has all the bits and pieces we need, right? And what we've done here is we've separated out the common elements for the car, right? So that's all the bodyworks, the suspensions, all that stuff. And then we have the two different bodies. So the kind of the shell that you have, because they use different textures there are two different drivers, right? Hamilton and Bottas. So for these two different drivers, we have different materials on the car body. So there are two different kind of shells. So depending on which driver's car you want to feature, you would turn one of them on and off. We also built a bunch of tires. As you know, for Formula One, you have different softness for tires, and those are represented by different kind of color labels, as well as grooves in some cases for the wet tires. So those are already built also. And we have the driver. The driver is actually quite simple, luckily, because we are mostly doing this, looking at the car from a distance. We only really have to build a helmet, right? The helmet and a very rough approximation of the body. We didn't need to rig the driver or do any like very detailed work on the geometry. The car that was supplied to us also didn't have a lot of detail. The green part is pretty much what we got in terms of car body. Of course, the suspension came with it too, but we have to add a lot of detail. So first of all, this opening here, which was actually added, I believe, a little later in the season, this one we basically had to add. So what we did was we cut out a piece here, and then we just kind of built our own little geometry here to kind of make it look like what we've seen in the reference photos. Of course, this car is made up from multiple panels, right? With that, we had to find a way to kind of show all these panel gaps. And we didn't want to cut into the geometry because that would just cause a big mess, and it's going to be very hard to kind of move around later on. So what we did was we just added these seam lines, and through some clever shader later on you'll see, we're able to kind of give you a convincing appearance of kind of panel gaps within these pieces. And then you have these little screw holes and everything. So those are all added on top of the geometry. So here's another view of that. So original geometry, and then we add these all panel gaps. Because these panel gaps and these screws are more or less floating on top of the surface, we want to make sure that we don't see that, right? We want to make sure that we don't see the shadows or reflections casted on this shiny black paint. So basically we just said we removed the shadow ray and the reflection ray from these accessories so that they look like they're more grounded on the body itself. So once we have the car done, we noticed a few other little details. So one is the model that we received, right? It doesn't really transition between parts smoothly. So if you look at the reference photo, this is the front suspension of the car. You'll notice that it's more or less a smooth progression. It's sort of casted out of one piece, I believe. So part of this, at least up to here, right, should more or less flow seamlessly into the body, which isn't happening right now. And you see this, very drastic change in normals. So what we did for these cases is we added a data transfer modifier. And what that does is we're able to tell it to basically blend the surface normal between one mesh to another. So once I turn that on, right, you see now that there is a very smooth transition. Again, I'll go back and turn it back on. So same here. Then you get this perfect transition without adding any geometry, right? This is just purely messing with the normals to make it look like they flow together. And this works well in rendering as well. Once the normal has been adjusted in the render, it looks like it's one surface. Another sort of technique we use to increase the realism of the car is using the bevel shader. So very similar to the problem that I described earlier. Sometimes we have pieces that kind of intersect, right, perpendicularly with another piece. If you think about how these things are manufactured, they're typically cast out of one piece somehow. I don't know how, but there's no seams. There's no visible seams as you see here. So by turning on the bevel node, and basically letting that control the normal and the clear coat, we are able to kind of add this artificial, almost like a blend between the two objects. The two pieces. They have to be one object for this to work. So again, we're not changing the geometry in any way. We're not even adding any modifiers. We're simply adding a shader that kind of bends the normals in a certain way. And this gives us a very convincing, effect. And it's very cheap to do. It's very easy to do. It's not super cheap to render, but it adds a lot of detail. Once we have, sort of the car ready, we started bringing that into the environment. We built some of the environment for previous work, but we also added changed the environments quite a bit. So this is one of the environments that you saw in the video. It's sort of like a paddock, right? There's a lot of detail here, and not all of the details you can see in the final video, but we wanted to build everything up just because the car itself is very reflective, and we wanted to make sure that there is something for the car to reflect, right? Otherwise, it'll look kind of plain and boring. So we built up this whole kind of room. This is how I typically work when I'm doing the kind of scene organization and look dev. We have your car here, right? And this car is it's brought in from the main file that I discussed earlier. So it's not editable here because, we want to make sure that if there is a change to the car, we only have to change it in one place. So we have the car. We have the paddock. So here, I'm sure you cannot see it, but here's the other geometry for the paddock. There's, these extra tires and screens and controls and consoles and all these stuff on the top. Here's like a big light box that they typically put in the paddock as well. And then on the very top is what we call the set. So this is where all the lighting and the magic is happening. So this is, the camera, all your lights, and then for this particular scene, we have a fog volume as well. So this is, your kind of virtual cinematography stuff. Okay, so once we have that all built up, we start adding the materials. So again, the car is already textured and fully materialed. We have, the paddock, which is relatively simple. It's, we just throw some materials together, and this is more or less what you get in Blender's EV viewport. And you can see sort of the low fog that we added. With this done, it's time to sort of work on the actual lighting. So with that, we played around with Eevee quite a bit, and these are some of the early images that we generated. So this is the paddock, as you can see. If you recall from the video, you'll probably recognize some of these images. So this one, there's that kind of car going through, the lights, the lines of lights, and then here's like the mirrors, the laser scene. So this is all done with Eevee, and they're relatively quick to do and iterate. And with that, we were able to sort of get an initial approval and get a sense of just what it is that we're looking for. And at this point, we already have some animation as well. I have some rough camera movements, so I was able to cut together a very rough, almost like a previs of what we want. But it's a fully rendered, fully lit previs. So this is why Eevee itself is so valuable, because it gives us a very quick way to create stuff. So from there, we started refining each individual scenes, like taking the scenes that were approved, we started refining them, right? So here is a later iteration out of Eevee. So we changed the color scheme a bit because we wanted to highlight some specific brand colors. And we started playing with sort of lights a little more and refining where we want the shadows to be, all that stuff. Again, this is done in Eevee because we want it to be really fast, right? So there are columns that we want to be lit, there are ceilings that we want to be darkened, and all of that is just much quicker in Eevee. Once we're happy with that, we flip the switch, we go to cycles. Again, this is cycles powered by HIP, so it renders exactly the same as it would on CUDA or optics. So you'll get the exact same result. There's no missing features with the HIP version of cycles, right? Everything just works. And with cycles, this is what you get. So with this particular scene, because it's mostly, direct lighting, it's actually really close, right? You can see the reflections on the car falls in the exact same place. The shadows are in the same place. It's very close, and really happy with that because it means we don't have to go back and fix things, right? With some other scenes like this one, Eevee doesn't give you the perfect results, and that's pure. That's very understandable, right? So in this case, because these are emissive things, they're not actually ray traced, right? So we cannot see them in the actual reflection of the car, which is mostly black, so it's very hard to really see anything, right, unless you have specular reflection. So in this case, the car is not quite lit the way we want, and we know this, right, going into the first initial animation. We know that it's not going to be perfect, but that's okay. We got the general look that we wanted, and then once you flip to cycles, you know, all of a sudden the ground is lit better, and then you see a lot more color and lights here. So this is our basic process where we just kind of go Eevee and then cycles, and then once we're done that, it's time for the final rendering. And for the final rendering, we tried a few things, right? So we wanted this in 4K, and we wanted at 30 FPS instead of 24. So, you know, there's a lot of data to deal with, right? And I don't really like using clamping in cycles, because clamping basically makes the scene less realistic, right? I like to use really strong lights and have it kind of bounce around the scene and have it naturally resolve itself, right? And if you talk to any render engineer, they'll tell you that's the worst case for rendering, because when you have really strong, really small lights, it's really hard to resolve those. But, you know, again, I have an aversion to clamping the light down. So my scene a lot of times end up with quite a bit of sort of, you know, fireflies and hotspots that needs to be cleaned up. So for this project, what we did was we experimented with using temporal denoising. So the way that this works is we basically render the frame at a lower sample. So let's say we wanted 6,000 samples, right? We render it at a third of that, so 2,000, okay? And then we just render the whole sequence. Effectively, you want to average the three together. So you take, for every frame, you take the, you know, the current frame and then the previous frame and then the next frame, and then you average the three together so that you effectively combine your samples and get 6,000 samples. Now, obviously, if you do it just by blending, the problem is you're going to get ghosting. So we used the motion vector data that came out of cycles to basically nudge the pixels back into where they should be, right, for the current frame. And then we do the blending. So you get very little ghosting, and then you get basically perfect tripling of the sample count. You know, I should say that you'll still get a little bit of issues in some edges, especially if it's fast moving. But for our particular scene, because it's very slow moving, it wasn't a huge problem. We were quite happy with the results. So as you can see here on the floor, you get a much cleaner reflection without some of these kind of hotspots and fireflies. The final video was all edited in Blender, and there's really no reason why or why not. We were comfortable with it. Everything's image sequence, and we kind of just threw everything together. It was a very simple cut. We want to focus on the animation itself and not the kind of the fancy transitions or anything. So, and we had to deliver this in 2 different formats. So 16:9, the regular sort of screen, and then a 5:4 for taller screens. And this will be for mobile consumption and whatnot. So for this one, we basically just did a pan and scan, like we just cropped it, and then we try to adjust the each individual clips so that we make sure that whatever is happening on the screen, the key action is visible in the middle of the screen. That's basically it. That's the process we used to create this animation. There are a few add-ons that we couldn't have done without photographer for camera management, especially for the still images that we did. Quite useful. Animated render border, also really, really useful. Let's say if there's a part of the car that wasn't rendered properly, or let's say if you have to change swap out a logo on the car, right? And let's say if this happens later in the production, you really don't want to re-render your entire 4K image. So what we did was basically we use this add-on to define a region in 3D space. So you're basically putting up a box, right? And then it will draw a border around it, and it will track that border around for the entire duration of the animation, and it will render out sort of an alpha PNG or EXR, it doesn't matter. It will render out a patch, right? That allows you to composite on top of your existing render. The only thing that we've learned with that is you have to just give it a little more extra border when you're doing denoising, because denoising will mess up the edge of the frames a little bit. So you have to just give it a few more pixels to work with to make sure that it blends smoothly with the existing render. For panel gaps, we use Deco Machine, obviously. And then for instance management, quick instances is really nice. And Camera Shakeify, I think that's the add-on that we use to kind of just give it a realistic camera shake instead of the random noise. So these are things that we used. Part of the goal of this was to find out if there are any production issues with using HIP and Blender. And I'm happy to report that basically there aren't any major issues, right? We found 2 bugs. This is just a feature that's not implemented yet. And then this one, we only found out later on when we're trying to do 2 instances of cycles at the same time. And both of these are reported to the team and they're being worked on. So, at this point, basically, as far as I'm concerned, HIP is production ready and it's on feature parity with CPU renderers as well as the CUDA and optics renderers. So yeah, I think that wraps up the presentation. Yeah, we had a lot of fun doing this, the whole team, I think, and we're really happy to see this being shown all over social media. I think people quite liked it. And it's just a nice piece of challenge for ourselves. So thank you for listening. And hopefully I'll be here to answer any questions. I'm recording this ahead of time, but I'll try to see if I'm available during the World Meetup Day to answer some questions for you guys. Thanks.
All right. Thanks, Mike.
Welcome, everyone.
Thanks, Mike. That was awesome.
Right.
It was a really great presentation. Thank you.
Cool. So yeah, I think the one thing that I could add, I do believe I have just a few more minutes, right, while waiting for any questions to come in. Yeah, I mean if you're wondering sort of why we picked those scenes or how we decided on those scenes, it was more or less driven by kind of the tech requirements. So, to test the renders, we want to do motion blur for sure. And then we wanted to have volumetrics. We wanted to have lots of small lights, right? That's what the last scene is. So, it was mostly like we had a laundry list of things we want to test, and then we try to create scenes based on those. So it was, probably not how you usually do this kind of animation project, but that was what we did.
Fantastic. All right. Well, that was great. I see her in the YouTube chat. So, if people have questions for Mike, please feel free to reach out. I know there's been some question and answer happening during the session. So thanks, Mike. I've dropped a URL to thepixelread.com in the URL. If there's any other URLs you want me to get out to folks, just drop them in the Discord and I'll pass them along.
Cool. All right. Thanks, everyone.
All right. Fantastic. Thanks, Mike. Have a great rest of your Saturday.
Thanks.
All right. So up next, we have another session from Jacob Merrill from Unknown Forces Game Studios. Jacob's going to be talking to geometry nodes and UpBGE, which is Accenture's redeveloped game engine from old Accenture days. Has been updated and reintegrated, and Jacob's also known as Blueprint Random, is actually an expert in this field. He's actually presented a couple times at previous World Blender Meetup days. So I'll drop a URL for UpBGE into the chat here, but for the next 30 minutes, we have Jacob Merle on geometry nodes and UpBGE.
All right, so today we're going to talk about streaming stuff inside UpBGE using GeoNodes and UpBGE guts. So I'm going to start off by deleting the default cube. I'm going to add a curve. This is what we're going to stream along. And then we're going to add a plane. We're going to do array, fit curve, pick the Bezier curve, and then we do curve, pick the Bezier curve. So now it fits on there, right? Then for the streaming part, we're going to add an empty cube. We're going to give it a constraint, path, Bezier curve. So it's on the curve. We're going to say follow curve, so it points the same way as it. And then when we crank this offset, it moves it along the curve. So now, add empty, single arrow. We're going to call this time. We're going to give it a logic brick setup. And you could just have the player moving along the thing move the path along the thing too. But this is for streaming, like the game moves no matter what, like the old side scrollers. So now we do always, and then motion. All right, so this is going to move down always. So we grab it. We add geo nodes to the road after a weld modifier. Bring that up above there. So in the geometry nodes, we can do input position, and then input object info, and then we want that empty. We'll rename the empty right now. Stream center. So we do vector math, and then distance, and then attribute, or not attribute, geometry, separate by geometry, and then we're going to do face, distance, and then we'll do utilities, math, less than, and then you could type like 45, 15. So you can see this is like the distance away from this that the road will be filled in. So now we can grab time. And we're going to copy its Z position. Copy as new driver. Then we're going to go to the stream center and go to its constraint and do paste. So now when I move time down, it moves the stream center forward. All right? So next, let's see what we got going on here. 5 minutes. So next, we can do a delay like every 15 frames for this to move up. So this will move forward every 15 frames. So we're going to duplicate the stream center. We're going to do camera center. And the reasoning for this is the camera needs to update continuously, whereas we want the road to only update periodically. So we have a camera center, we have a time, camera time. So we take this and its Z component, we copy it, copy as new driver. So we go to the camera center, we go to its constraint, and we paste this in over. So now, when I go to camera time, this is going to be always, every frame. And we don't want rotation. Weird. -0.5 for this, or we'll say -1. So it's every 15. And then this one, If it's every 15 frames, 0.1 should be the same. Let's see. I'm gonna have to pop something on the camera center so we can see it. Add mesh cube, camera center, Control P. All right. Huh. Oh yeah, I have to do this. So we do override transform priority on both of these, the stream center and the camera center. All right, it's going backwards. That's right. Negative 0.1. There we go. So now the camera moves continuously, and then the road streams every 15 frames. Looks like I need to take this. Let's see if that does it. Yep. So now it's perfectly centered. So it's streaming the camera every frame, and then every 15 frames we update the road, right? So then next, when we update the road, we're going to need to actually set a property in the road. Update. All right, so now that I have that, we assign property update to 5. We set it as an integer. And then inside the road, we do property. Oops, this is what's supposed to have update. All right, there we go. So now, every time the time moves, it sets the property update to 5. So now, we need, if the property update is greater than 0, or greater than 2, and then edit object, or no, property, sorry, add -1. We have to set this to true level pulsing, so it'll reduce it down to 1. And then we do property is equal to 1. We do Python, and we do tap here. I'm going to do a text. Templates, Python, game logic simple. Own.reinstance physics shape. I think it's physics mesh. I think it's shape actually. We'll see. And then file save as stream test. All right, so update equals 0. All right, so we should see this pulsing. We'll set it so we could see the debug properties up here in the corner. All right, so that's running. So now I need to set this to triangle mesh in physics. And then we'll turn physics visualization on. Okay, it's not calling the script. We might have an error. Let's see. every 15 frames, but it's never getting a chance to do it. Oh, duh. Greater than 1. There we go. All right. Physics mesh. Okay. There we go. So now we're streaming inside the game engine. So with setups like this, we can cull a bunch of the geometry or not generate a bunch of the geometry. And it makes it so we can stream worlds very quickly. So there's the basic setup of one. Let's see how long we are into this. We are 11 minutes. Okay. So there it is. So here's another streamer that I set up the other day. And this is spawning buildings that are made of instances, and we're updating both sides of the road. And you'll notice we're getting 270 frames per second, 300 frames per second. We have a pause when it updates the shapes sometimes, and when it reinstances the physics shapes. So it's generating all this in real time. I'll just go ahead and zoom out so you can see what's going on here. So this gets moved around here, and then these get snapped to it periodically, and that tells it when to update. So we're not updating constantly, we're deciding when to update. So let's see, I think it goes this way, so we can go all the way back this way. So deciding what to update piecemeal actually makes it much faster. And we don't have anything like AMD super resolution yet, or anything to be able to boost the performance. EV rewrite is on the way, should be here pretty soon. And before we go, I will just show some stuff on Chrome. So let's see here. I have another streaming system. Looks like I went back too far. Trash Panda, there it is. So this is kind of my main project. I walk away from it and come back to it, called Rectified. And this is all generated in real time. I have real heavy depth of field and some things like that for atmosphere. You'll notice on the signage it says food and ammo. Those are generated randomly, but there's like food, ammo, and medic at the moment that it decides from with an index using a random choice. So here's that file. So again, we are moving along a path, and then we choose when to move empties to update the left side of the street, the right side of the street, and the road. And we split the updates. The more the updates can be split, the less the impact you have on your streaming. So it's, again, the same concepts that I showed in the streaming of the road at the beginning, but applied to a city. All right, and then another use case is the particle fountains and particles. So one thing I was able to do is run particles inside the game engine, and then while it's running, I record copies of the mesh and set them aside and disable their geonodes. So what it basically does is caches that frame, and we add those to a collection, and then we can use their collection indices to access them. So basically I cached it using UPBGE, and then each frame at the end of the simulation, we'd take the data, the evaluated data, and write it back as the original. So it takes the positions and just moves them around, basically. So we can simulate physics in real time using geonodes plus UPBGE. So we'll go into the evaluated data real quick here. File, open recent. Looks like we have to go a little further back in time here. So I'm going to look at the videos again. Here we go. So we have an evaluated mesh, and then with mouse over, I get the indices of the slot, and then I pass that into the geonodes up here. So I'll go ahead and open that file now that I know it's named. It's called geonodes inventory. So we'll pause that. Oh, I have to open it from here. File, open, Google Drive. There we go. So we have all of these get generated. They get their texture from one of these, this slot info. This is their UV info. And then there's one dot here for every single face over here. So when we run this, when I mouse over something, if I click, I can adjust the dot that's associated with that face and set what UV it's using. So that's what this is. So if you're mousing over, if it doesn't have a BVH tree, grab the BVH tree. And if it does have a BVH tree, then use the BVH tree. We get the mouse over position, and we use it, and we set the slot there. And then this is to fill a slot right here. This is to adjust the indices, adjust the vertices position associated with that slot. So we can use this stuff to do like tic-tac-toe or an inventory in a game or like a menu at the beginning of a game or whatever. So yeah, we can edit data and we can display data and we can get the evaluated position of the data. So these are important snippets right here. So I'll leave this open for just a second here. Okay, so I have about 10 minutes left here, so we'll go ahead and see what we have on deck. Oh yeah, so I have a new generator here. So this generates random buildings, and it's going to be inside of my streamer. This W value is the W value for a Musgrave texture 4D. These are generated based on, let me turn all this off real quick. There we go. So there's the base shapes that we use to generate those. If I turn this on, it extrudes edges randomly out. and then it does again, but when it casts and when it goes to put the edge out, it ray casts where each edge would go, and if there's face there, it won't do it. So we can get these complex shapes. So there we go. We got some generated buildings that have lots of different shapes. These kind of overlap just a tiny bit, but I think that's because of the simple deform. Nope. I'm gonna have to check that later. Well, I'm gonna have to give up the last 8 minutes of my time. Thank you for watching. All right, so today we're going to talk about streaming stuff inside UPBGE using GeoNodes and UPBGE.
Hi all, and that was Jacob Bernal on UPBGE and using GeoNodes to create some interactive content. So hopefully y'all explored the link on I always thought it was pronounced UpBGE, but I guess Jacob would be the expert there. So upbge.org for more information on that. It's a very capable game engine, and people are building some pretty neat stuff in it. So that's fantastic. So I'm just checking. It looks like we've finished a little bit early. We have about 10 minutes before our next presenter comes on. So I'm gonna just, for the next 10 minutes, we're gonna get to enjoy some open movie content. So thanks everybody, and I look forward to the next session.
Welcome everyone.
Done. But actually, this one.
Hello, Mr. Snail. Oh, you cute little cornua sparsome. Latin name, bonus points.
Oh, can't believe we got stuck with the tree hugger. If I have to hear the Latin name for one more animal, I swear I'm gonna kill her.
Relax, Sugar Buns. While she does all the work, we'll have all the fun.
Yeah, and get wasted out of our minds.
Way ahead of you, man.
Come on, team. We mustn't dilly-dally when there's so much nature to see. I was thinking we should call our class project Fun Guys in a Forest. Get it? Because we're a group of fun guys and also fun guys. Shush! That's a low wagtail, and she's in distress. There, my little Montezella flower. Oh, look at her go. Wow.
Out of the way, dorkwad. We're camping here.
Finally. Time to get that barbecue burning.
Oh dear. Easy, guys. We're supposed to be studying nature, not wrecking it.
Piss break. Oi, fungus freak. Make yourself useful and fix the tent.
Oh, a bit of friendly campsite ribbing. Fun.
She wouldn't survive 5 minutes alone in these woods.
Yeah, she's a real weenie, that one, isn't it?
Oi, Phil, how are those sausages coming?
Almost ready. Just need a bit more salt.
It's incredible. It's a new species.
What the bloody hell are those things? It's like a note shagged a mushroom.
They're absolutely adorable.
Yeah, absolutely bloody adorable. And I bet we'll make a fortune if we catch one of those things.
We'd be famous.
Get on MTV. I wonder what they taste like.
Oh, we really shouldn't disrupt their habitat.
Right. Sure.
Greetings. Welcome, friends. I'll be right down. Could I interest you in some peppermint tea?
What are you guys?
We are sprites. We sprite balance to the forest. We take care of the animals, plants, birds, nuts, ladybugs.
Guys,
Hey, little mushroom geezer. You cool with us camping here for the night?
Absolutely. A friend of the forest is a friend of the sprites.
maybe it was just ketchup or something, like red paint? Yeah, maybe they were just painting their little hats or something. Guys? Guys, this isn't funny. Guys?
We were just gonna catch one, but they're psycho! You've got to get me out of these, hurry! They're gonna kill us!
Right for left for leaf and stone. You picked the wrong camping spot, bitches. Sprite them!
Sprite this! Sweet
Those punks treated the world as their own personal rubbish bin, and you set them free. Now you'll join them. I'll give you that one, Brother Bird. All right, sprites, let's burn the bodies and have some peppermint tea.
Keeping watch wherever we roam. Die-dee, die-diddly, the forest is our happy home. Woo-hoo-ha-ha, be all together now. Friendly sprites rise with the sun. Friendly bees, friendly gum. We won't stop till the day is fun. Friendly, yum-yum.
Danger, danger, I'm a forest ranger, about and clear the way. I'm about to blast it, stick like plastic, what your mama gonna say? I'm about to drop it, stanky, plop it, I'ma just catch in steam. Now pillage and loot it, I'ma pollute it, lake to the river, to the stream, splash! And call me cavalieri, try to cut me down to size. Nowadays my announcer, driver, bouncer, baking me cakes and pies. Yeah, this camp is a call-out, here come the fallout. Me and my crew don't play. My boots on the log, on the leaf, on the frog, cut words in the tree to say, hey, hey, hey. Silicon rock, silicon rock, silicon rock, silicon rock.
All right, that was Sprite Pride. So pretty awesome that we get to watch the movie after we talked to the artist that created it earlier, right?
That
awesome
is pretty. Indeed.
Yeah, we get to see the making of and the final thing. So so I was thinking, Dave, maybe we rotate to Oscar.
Yeah. Do you want to? We can play Oscar. His session's about 30 minutes long.
Sure.
And I could also put another session up from a different speaker. So yeah, what do you guys say? Watch Oscar's Seabug session.
Hey everybody, Oscar.
So we can do that.
Okay, fantastic. I have Oscar's session here. Let me just get that queued up. Give me a sec.
Yeah. You tell me when it's ready and I'll switch back to the main monitor.
All right, sounds good. Let's see.
So just to do a little scheduling check. So we, where are we at? I think we're right down to like UTC 2030, right?
You mean when do we end today?
No, so right now what sessions? We haven't gotten Damien, correct?
That's correct.
Jewelry. All right, so we're gonna replace Damien's slot with Oscar from Seattle, who we missed earlier. And Matthias and Vancouver, are they still good to go?
They are. However, so we'll play Oscar, and that's a 30-minute slot, and then we have another 30 minutes prior to Matthias.
Okay, so we have another 30 minutes. So we'll probably find I'll find us a good 30-minute slot to put in there.
Okay, great. And for people that are just joining us, we are going to play Oscar is the Seattle Blender user group lead. He does quite a bit up there. Actually has a like a regular Discord live stream that he does. He's really prolific and a really nice guy. He's put together this video specifically for this World Blender Meetup Day. He apologized for the audio in advance, apparently recorded at an airport. But This is
Yes.
Oscar on grease pencil work in Blender.
Cool.
And yeah, you may need to turn up your volume for this one.
All right, go ahead and play it, and let's see. Yeah, why don't you crank it up just a tad in VLC?
I have great news. Cbug is starting up again. Let's go to
Okay, great.
meetup.com/cbug. You'll notice that on April 2nd, we are going to be returning to in-person meetings. I'm so excited. Soon I'll have this new banner up. And we meet every morning, or 2 years ago we used to meet every Saturday morning, first Saturday of every month. And we're returning to that, so it's from 10 to 12. I can't wait to be in a room full of my favorite kind of people and just nerd out about Blender again. Today, I am here to talk to you about grease pencil materials. I am working on a new book for Pact Publishing about grease pencil in Blender. And I wanted to show you some of the things that I think somebody who is new to grease pencil should know. So number one, there's this 2D animation preset. And we're going to be going between two major things, which is the preset brushes up here with the draw tool. And each of these has some sort of variation in the radius and strength and some of the other features that you'll find in the advanced or stroke menu. So most of these, like you just play with, you can usually see how they work. Mostly I wanted to talk about materials though today, and just as a starting point, you'll just jump between these basic presets and some of the starting materials as we modify them. So let's start with how you can modify the tools. Over here you'll notice that you've got your brush preset, and mostly I use these menus up here, the stroke and advanced menu. But over here in the tools, the one extra thing that you have is in brush setting, you do have some curves for this. So one thing I like to do is, just as a demonstration of this, I love trying to figure out how I can make things feel like a real world material. And so I think Sumier is one example of this, where a lot of times that will gather ink, like you dip your brush in water, you then dip the tip in a little bit of ink, and you just barely hold the pen to the surface of something, or the brush, and just the tip will touch something, and it will be a very light thing, but it'll be very concentrated ink. So if I, so if I change my radius, if I have my strength on an opposite curve, what'll happen is that with light pen pressure, it'll be really dark. And as I push, it'll get lighter and bigger. And that's just like with a Sumier brush, where oftentimes, like, at the start of it, it'll be very, very intense, and then ramp up as you go. So now when I do this, I'll just use that light touch, get these fine lines. Yeah, even better is like if I'm using something like full opacity, so it's closer to a pen. I get these dark strokes with light pressure, push harder, and get a wash to my brush. Please save these things. Well, you can go over here and create a new user, and you can add a special image. I love just doing this inside of Blender. Why not just draw a picture and save that? First up, let's talk about stippling. So stippling is a drawing technique where you do lots and lots of tiny little dots. I remember having to do stippling in my high school art class, and I hated it. It felt like busy work. It just seemed like the teacher was trying to make sure that we weren't messing around in class. But I love it in Blender because you can cheat and make the stippling happen really fast. So I'm switching to the pen preset, which is close to like a micron or a pigment liner. And I'll set my radius to 5. And I'm going to switch my material to the dots stroke. This will make it so that I just render one point and I don't draw the strokes in between them. At first, you'll notice that even with stroke jitter turned on and pressure off, it still has a certain amount of linear element to that. That's because of two things. Number one, you have post-processing, which is sometimes smoothing it out. You also have the input sample. So if I turn that way low, now it'll very slowly sort of gather around. So I can sort of start rendering this little art school small screens, right? Notice how quickly this builds up. Now, as I go, I'll just increase the input samples and reduce the jitter. And now it'll get darker and darker. And really what I'm trying to do is get to some sort of value scale that goes from black to white. The other thing you can do here is, as you build this value up, eventually you'll get to a point where you're at like 0.001 jitter or even no jitter. And at that point, you're really actually using the linear line quality. Even there, you can see that there's some jitter. So if I turn all this off, turn randomize off, now I can do things like get this contact shadow on the ground. As you build this value up, one thing you can also do is switch to edit mode. And I'll just use circle select to grab some of this. I want to be on point. And if I turn off overlays, now I can just shift D this, duplicate these. I can get that nice thick opacity. And then lastly, I'll switch to sculpt mode. And if you're duplicating this and it starts to look a little repetition, like you can see this sort of star streak almost, just go in and randomize it, and that'll like hide that a little better. So you do this long enough, and you get some sort of stippling render. There you can see, these are figures from my new book, where you can see I'm just experimenting, trying to make gradients, and trying to make different, soft edges and hard edges. Let's talk about pointillism next. Pointillism is similar to stippling in that it's lots of little dots. This is done by guys like Seurat and Camille Pissarro to make paintings. I'm going to start with the pen tool, or the pen draw tool. I'm going to up the radius to 1,000,000. Set my strokes to randomize and jitter. I'll turn post-processing off and input samples way down. I'll actually type in a radius like 2,000. Doesn't let you go that high unless you type it in manually. And for my color, I want to be on that dot stroke material, but I also want to turn on vertex colors over here. So this will make it so that if a vertex color exists, it overrides the material. And this will put vertex color information on each stroke using this chosen color. So I'm going to choose a nice brown. Next, I'm going to go into my randomize and set this to 0.25 and modify. Oh, wait, no, that's not it. Not the radius. I want to randomize my hue by 0.25, my saturation by 1, 0.1, and my value by 0.1. So the theory in pointillism is that you have sort of optical blending in which you put a very saturated you can also turn on simplify, so like 0.2, and this will make it so that it removes points in between points. This will make it so that you get very few dots to start with. See that simplification? We're just getting a base canvas in here. Nice. So the theory of optical blending is that a dot of saturated yellow and a dot of saturated red next to each other will optically blend and feel like an orange, and oftentimes feel more saturated than actual orange. You'll see this in like people's rendering where people always put extra like secret red and stuff. What I like about this is as you go, you just lower your brush a little bit at a time. Maybe start with some sort of base drawing here. I don't know, coffee mug or something. I'm going to turn the jitter off. Set my simplify to 0.01. I don't need nearly as much. So maybe we're rendering a nice bowl or something. A bowl of fruit. So one of the good rules for painting that I've discovered is try to just get everything covered as soon as possible. Pardon the audio, I'm in the airport right now. That's my brother. He's on a trip with me. Are you recording? Also, cool dude. So, as soon as possible, try and get as much of this like locked in as quickly as possible. And you got your colors. Just, one thing you learn if you paint enough is that like you spend a lot of time on the first chunk of it, and then it's time to close up for the day. It's just annoying to have to not have like enough progress on the day. So like so much of this is like based on your artistic experience of frustration that you didn't get as much done in the day as you would hope. As quickly as possible, just get it in there. When you take this long enough, you take it far enough, and you get. You get a pretty nice render out of it. So here's just major settings that I change. A lot of times I'll lower my strength for things where I'm trying to blend, and then for something like these edges here or a highlight, oftentimes like you scumble with light paint in real paint, and then your last touch you go like real opaque for the light. What else can we do with grease pencil materials? Well, so far we've mostly been messing with brushes. I think another thing that you can do is add a texture to it. So if you've never done this, you get very different results when your stroke is set to a dot stroke versus a connected stroke. So here's a couple of examples that I've done. Just to show this, you go to like texture on it. You can load in a texture, and one thing I would say is if you're making your textures in Blender, what you'll need to do is when you create a new image, if you're just making a 128 by 128 stencil, this is going to start with a combination of the alpha of the image and what you're working with. And it's a lot easier to add the alpha in from 0. So start by clicking on this and bringing the alpha down to nothing when you start off. And now when I go in and I make my stencil,
And thank you for you guys are awesome. Thank you so much for donating your bags, not donating, but handing us our bags. They will go to the Border Baggage Claim in Las Vegas. You guys made me feel like a really good salesperson.
So now, since I'm starting from like alpha of 0, not sure if I want my mouse here. Now, like as a result, the alpha will start off basically only appearing when I use the brush. So if I go on and draw with this now.
All ready for our passengers
Create a new
going to
material.
Tucson, 2249. Looks like we have a gate change. Going out of gate 2B. 2B. Sorry, this took a little bit longer, and they had to move that plane out
So
there.
notice how
Get out of here.
right now,
So Tucson passengers, gate 2B.
yeah, where's my material? No, I think I was playing animation stuff. Creating new pieces. You'll notice that this is repeating over and over. If I set this from line type to dot, instead it's going to be a lot closer to what I want, which is sort of a stroke that's repeating, almost like a bristle brush. Note that it uses the color of the texture, so it's not like a Photoshop brush. It's actually using its individual color. You can change this by upping the blend. So I'm up in the blend, and this whole time I've currently gone to bar. You have randomized for the hue, saturation, and value. And then the other thing that you'll find is that you can have the stroke be along the path or individually. And what I find is useful is you can also have it be completely random by turning on randomize the UV of it, and that will make it so that for any given point, it's going to be totally different.
Thank you so much, Vegas. You guys, I appreciate you for being
So what about like the option of using a line? So this is really cool. You can have a texture that repeats from left to right that follows this. So like what you want to do is make sure you start from a texture that repeats left to right. This was a tentacle that I made from reference and just really quick in Krita. It has a really good wrapping tool. You can also turn on UV wrapping in Blender. Resheet image, and this allows you to like see that it repeats. So when you make a texture that repeats left or right, you can then load that in on the solid stroke material, for instance. So the line type is set to line. You have this, and I love using the curve tool for this. I changed the thickness profile to be exactly default. So I think like the default is something like that, and that's going to start small, get big, and big. I want this to start big and just go from there. And now, I'm going to drag this out. It'll repeat along there, and I can hit F to change the size of it. You can make some pretty cool tentacles. The other thing you'll want to do is in your material setting, look at the layer settings actually. One thing I have changed, notice that this tentacle is in front of that tentacle, so it feels like a 3D object. The reason that's working is that in the layers panel, I have taken this layer and in the I believe it's in the strokes draw order, I've set it to 3D location, and as a result, stroke 1 will be drawn on top of stroke 2. If it's set to 2D layers, sometimes you can have problems like this, where it's drawing the strokes in the order that they were created, rather than what's closer to the viewer. So just make sure you do that with your layers, and you can get some really cool effects. The other thing you'll do is change the UV tiling over here. You have this tentacle be more or less. So just to show like some other examples of this, like a quick braid that I made. Make sure I'm moving really fast. Now the last grease pencil material I wanted to talk about is fill materials. So if I create a new file, I'm going to switch my solid stroke to the solid fill, and let's go to that solid fill. One thing that can be really frustrating is if you have a texture for this, such as a screen tone here. Now I've got this box here, I'm going to hit enter. And this has a screen tone texture on it, which is basically just a single dot. It's similar to like what you see in like old school Ben Day dots for comic books and anime. And I like starting off from just big rectangles of this stuff. The reason being that that's how they did it. You know, if you go back in time, the way that they would do these is you would get printouts of screen tones that were actually on transparency. You'd X-Acto knife it out to fit the thing that you wanted. So if I lower my scaling to like 0.01, I start getting that screen tone look, right? Any guests with disabilities who need extra time or assistance are welcome to board. What can be really, really frustrating if you don't know how these work is it doesn't have any of like the fancy things that we expect from Blender material. You can't necessarily control it by UVs or world space coordinates or a node. The way that these textures are determined is you'll note that if I go to edit mode, the core principle of it, if I select all these and rotate it, it's rotating. But if I move one vert, it's not. So what's going on here? What happens is it generates UV coordinates based on the relationship between the index of the first and second vertex. So like you'll notice that this one, if I move it, does nothing. This was probably the first index vertex, and it is moving around. And almost like a Bezier handle, the second vertex also controls it. So you almost want to like select all these, and dissolve the ones that you don't want. And now you can basically just control your rotation with this little guy here. So if I start duplicating these, you get some pretty cool patterns. And, you know, when you look at comic books and stuff, a lot of times, like, they have these patterns, but then they do interesting stuff with it. So probably the most common thing you would see is something like line art on top of this, and they would just make it fit that. So I'll just got my pen on this paper material. Oh, true. Something I have.
And we now like to welcome Group B and the Beautiful. This is our last time I was attending the premium class, and one more Group B member.
And you would then have a mask layer for that. So,
and again, if you are in the boarding area waiting for
San Diego, or Tucson. Those are leaving out of gate 2A and B. Just on the other side of the terminal.
Add a new solid core material. Something like that. My screen layer, I can use a mask to control that. Here's my mask layer. Now the other thing that's kind of cool about this is we're going back to that idea that you should start from one big rectangle. So if I go back to the screen layer, I'm going to duplicate this guy and move him to a new layer called gradient. Let's change its material to a new one. Material. Now the other thing that you would see in comic books is all sorts of, novel ways that back in the day with, actual like physical screen time, they would make the screen tone transition. So this could be like building up multiple screen tones. It could be like scratching away at the little dots on that transparency with an X-Acto knife. And once we got digital, we were able to add like gradients. So I'm going to switch this to a gradient, and I'm going to have it go from a base color of actually white to white, but I'm going to have the secondary color have 0 alpha. So somewhere in this, maybe I'll have this actually be. Yeah, see that transition going on there? So what I, again, think is just kind of the best way to do this is start with this, and then just have these like chunks handy. Go around with this. And I can actually set this to, I think, a holdout material. And this will actually just affect everything below it. And you can start getting something that's pretty easy to control on a 2D animation plane. So the holdout setting is basically an eraser, and wherever you draw this with this, it'll erase whatever is below it. So the other place that you'll see the holdout shader is when you trace a bitmap. So if I have a new example grease pencil file, I'm going to go to object mode. I'm going to import an image, a reference image, such as this. I got all sorts of sketchbook drawings from back in the day. Here's some warthog exterminator I drew. And once you have this, you can convert it. So I'm going to switch to object mode. I got this. Let's go to object, convert, trace image to grease pencil. The main thing that I found is that if you want this to be accurate to the drawing, set it to 1. And you can mess with these other scales. The color threshold is kind of like the level. So if I set this bigger, it'll use more of the darks in this. And I'll get this automatic. Grease pencil works hard. The other thing is that happening here is that this actually makes it by generating a holdout material. And so it's simultaneously adding strokes and deleting strokes. So that's grease pencil materials, and I hope that you had fun with this. Again, sometime later this year. I hope that you buy my Grease Pencil book, or at least torrent it. No, don't do that. And I'm so excited that user groups are coming back on, and I'm so happy about World Blender Meetup Day. Way to go, guys. Blender is a global community, and it's just, you guys are my best friends all over the world. So, have fun. Greetings from Seattle.
All right,
Hey,
and that was Oscar from the Seattle Blender Users Group. We want to thank Oscar for joining the event, even though he couldn't be here in person. So I see we have Damien Rohrbach on the line. Damien, are you with us?
Yes, hi. How are you?
Hi, how are you today?
Fine, fine.
Okay, so we have had I think a schedule snafu. We were looking for you at 12:30, but sorry, that's I guess local time. We were looking for you a little bit earlier today and didn't see you, so we rescheduled and put Seattle on. So we have to make a decision here. So we've got another 24 minutes where we could either give you a half-hour slot, or we can try and schedule you for a little bit later in the day to get a full 60 minutes. What would be your preference?
Was I wrong about the time?
I think you may have gotten the time a little wrong. Yeah, we were looking for you in Discord and online, and we didn't see you. So
that's weird. But yeah. Okay, let's make it later. 1 full hour.
Okay.
How long?
Right. That sounds great. Why don't you jump on Discord? We'll work through the logistics of that.
Okay.
All right. Thanks, Damien. We appreciate your patience.
No, thanks to you. I'm sorry. I don't know what happened, but that's okay.
No, yeah, I'm not sure what happened either, but that's okay.
That on Discord. All right.
We'll work it out. We're really looking forward to your session.
Okay, thanks.
So, okay, cheers, folks. So what we're going to do then is we're going to rotate to a session from Michael Seda. I'm pretty sure I'm pronouncing his name incorrectly, so I apologize. It's Michael, I think. And he's presenting from the MetaLab up in Canada. And he's going to show some new and unusual ways to use Blender. And yeah, so we're excited to show this session during North America. If you've been with us since European time zone, you'll be familiar with them. So take it away.
for the youth and adults in all aspects of, or at least many aspects of digital creation. And we have also hosted immersive experience symposium for several years. We had to take pause because of the pandemic, but we were able to provide a venue for meetings with people and building, contacts and relations with people in all kinds of industries and the creative immersive world. So while I'm talking about the SAT, you can see a little bit of the context. The SAT is located in Montreal, in Canada. And here are some pictures that represent the SAT and some of the activities. And here is some information on the website. The building blown up, and here is the same information in English. So the SAT was founded in 1996. That was actually the fruit of the ICEA conference in 1995 that took place in Montreal, ICEA being International Symposium on Electronic Art. And the SAT is a non-profit organization. And in fact, it has grown a lot in the past 25 years. We're very lucky to be where we are right now. We own a building that's in the heart of Montreal, and we've evolved a lot. And so now in the building we have a restaurant which is located on the top floor of the building, next to the dome. And we also have a cafe that's open during daytime, and occasionally for some special events in the evening. That's on the ground floor, and these two complete the list of departments that I've mentioned before. In addition to a very virtual department, which is satellite. And which is in fact a very innovative place for us, because we are talking about virtual reality, focusing on virtual and hybrid experiences that involve Mozilla hubs and immersion, the course. So these are satellite is the latest addition, in fact, to the SAT's activities. So on the MetaLab website, you can find out a little more about what we are and, well, who we are and what we do, and the different kinds of projects that we're working on in terms of research and development. And this all centers around immersion. There are many different things that amount to immersion. There is video mapping, there is audio specialization, and also interactivity that play an important role right now in our work. So there are some projects here that are sort of fading out. For example, this one, Edition in Situ, is slowly being phased out. However, there are many very active projects, live pose for pose estimation and capturing of human interaction via deep learning, Splash, which is a video mapping software, and Calimero, which is still a work in progress for calibrating structured light. The audio specialization suite, we have quite a few projects that are going on. SATI, which is an audio specializer, which also has a capacity of synthesizing sound and doing all kinds of audio processing. Audio dice is a set of speakers. I will speak about them a little later. They're kind of spherical multi-channel speakers, and Varus, which uses ray tracing techniques for generating virtual acoustics. And then telepresence, that has been a flagship of the SAT for a very long time now. Telepresence chapter develops Scenic and Switcher. Switcher is a software that allows for distributed performances. In fact, it can send all kinds of data via the internet to different kinds of locations in different configurations. And when I say different kinds of data, it's audio, video, point clouds, MIDI, open sound control, and things like that. And Scenic is its front end. So this is the SAT. The projects that are of interest for us that use Blender in some ways is Splash. And Sati in a way, and we also do some prototyping, which I will be showing a little later. For those of you interested in Splash, it's a video mapper that uses an approach a little different from other video mappers. So we basically provided a 3D object to map on, a 3D model of the space that we want to map on. So a little bit about myself. I have background in music, mostly music and electronic music. I was interested in interactive systems for a very long time, and gravitated towards digital arts and technological arts, and that includes performance in installations. And so Blender was actually in the center of my toolbox in many situations. And in fact, I discovered Blender back in '96, I think, or '97. That was before it has become open source, and was very excited about the workflow and the possibilities. And so I think that actually the workflow that a lot of people were complaining about, the keyboard oriented and mouse oriented without menus, I actually kind of like that approach very much. And so I was using Blender on and off, sometimes for actually making some works, but I was mostly fooling around with it. But I would prepare sometimes some assets for certain works I was doing. And when I started working at the Metal Lab in 2011. It was obvious that Blender was going to be a part of our toolbox. So I will show you a little bit how we use it across the different projects, so that you can have an idea of how we do it. So one of the important aspects that are taken into account is the interconnectivity between software and hardware. So we always make sure that different tools can communicate with others in a fairly easy way. Most of the time that happens via OSC, for example. So some of our tools, those that make sense, use OSC for exchanging data. OSC stands for Open Sound Control. And then we have also developed a glue called shumdata, which basically uses shared memory to send different types of data from one application to another. It also serves for sending that data over network via switcher. So, for example, Splash uses shumdata to receive meshes, for example, from Blender. So someone could be modeling a mesh in real time while his or her projection or her work is being projected in some kind of immersive space. It also is very handy for prototyping projections and things like that. So we also work with open source software almost exclusively. So for the software that we develop is all open source. And also we usually make sure that the libraries that we use are also open source. So this way we perpetuate and contribute to the open source software community. And to talk about long Blender's history at the SAT, I should not forget about talking about the immersive view, which maybe some of you know in the cycles renderer. If you select the camera, there is the panoramic view with a fisheye equidistant, for example, view, which allows to render a spherical view like this, which is very much adapted to the dome, and that was developed by someone who is a part of the Blender team, as far as I understand, and his name is Dalai Felinto. He, as far as I wasn't at the SAT at the time, but I think it was in the context of some kind of residency that he developed at least the first prototype of this view. And so here is another example of a view that's straight from Blender, and on top of that uses some ways of projecting one object inside another into another view. And this is another prototype of a immersive view in like regular Blender internal engine, and some point clouds assembled into cubes and things like that. So we like to use Blender in many different ways and experiment with this. And this also shows how it is used for configuring Splash, which I will show in a minute. And of course there is our shim data, the memory sharing approach. So here we can see Suzanne in Blender on the left. Unfortunately, this is only a screenshot, but trust me, it works really well. On the right, we have Suzanne in Splash, and they're interactive. So if Suzanne in Blender changes, the Suzanne in Splash will change as well. And so I spoke about Splash before. Here you can see an older version of Blender that is being used to make a Splash configuration. So there is an add-on for Blender that uses nodes to allow configuration of a project, of a Splash project. So basically, we identify where are the cameras, the projectors located, and we prepare the 3D model onto which the image will be projected, and with a little bit of UV map magic and the coordinates of the different objects that are created in the 3D scene, including the cameras. Splash takes that information, and then that allows Splash to start to having like a very first projection that's coherent with the space. It needs a little bit of calibration afterwards, but the add-on is a very important step in the creation of the projection mapping with Splash. So in the spirit of using Blender as a prototyping tool, we use it, for example, as you can see, for mapping facial expressions and facial movements onto a mesh that also looks like a face, and so that was a project that we were developing at the time with some different partners, and this was like then the very initial prototype of this kind of use, and it turned out pretty good in terms of using this kind of tool to make this kind of prototype. And in fact, this prototype evolved a little more to the point where we were making a head model via photogrammetry, and after cleaning it up a little bit, we were able to create a rigged face with that was resembling the person that was scanned, and via the use of some software, face recognition, of some face recognition software, we were able to map, control the rigged face of the person that we scanned, which was a really interesting use case for us. And also what this opened the door to was being able to work with people who are not familiar with all the different programming pipelines, but are familiar with Blender, for example, and be able to integrate some of the work and work directly in a software that was approachable and that was let's say easy for them to manipulate, and of course that cuts overhead of having to write a tool that does this kind of thing that Blender already proposes. And here is an example of a use that's a little more mainstream, if you want. This is our prototype of an immersive environment for prototyping immersive scenes, and the first version of it, the first prototype, was actually built in Blender, and we've considered Blender Game Engine, but the Blender Game Engine was already sort of being phased out, and so we used the immersive view that we had in the Blender internal engine, and so and we added functionality that was necessary to connect some controllers, wireless controllers, and interact with different objects. Even change the meshes, so model things, do a little bit of painting, UV painting, and things like that, navigating inside the world. And so this was our way of trying to help artists who come to a medium such as the DOM, and maybe it's their first contact with the medium, and before they actually start producing works, there is a little bit of a period of adaptation, and we were hoping that this kind of tool could help people to quickly prototype things, sketch things up in the space, in the 3D space, and then export their creation as a, in this case it would be a Blender file or a GLTF file, and so they can take it home, rework it, and then when they come back, they can concentrate on actually working on the details and hopefully getting the work done with less back and forth going between their flat screen and a DOM. So.
Okay, I think we're going to stop there. There is more to that presentation, and you can see that a little bit earlier on our stream today. So we wanted to air part of that stream during North America time zone, so that worked out nicely. I see that we have Matthias on the line. Matthias, are you with us?
Yes, I'm here. Can you hear me?
Yeah, I can hear you great. How are you doing today?
Let me show my video. Yeah, I'm doing great. I had a cool day. I have a very old car, and I just had a tour around the country. It's a Ford Model A from the 1929. So.
Oh, that sounds fun. A tour around the Netherlands. Oh.
Yes, exactly.
Okay. Yeah, I figured somebody that has an interest in modeling architecture and landscape,
and historical stuff.
You probably get out quite a bit. Yeah, that's fantastic. So you're collecting reference, huh?
Yeah, exactly. It's all for work.
Awesome. Okay, well, hey, we're excited for your session. So understand that you're going to be speaking to rigging ships with geometry nodes. So we have you scheduled for 30 minutes at this time. And if you could just introduce yourself to the group, introduce the topic that you'll be speaking to, and then you have the next 30 minutes. It's all yours.
All right. Yes. So I'm Matthias de Rijk. I have a little one-man company called Mr. the Rich, which is just my last name in English. And for the past years, I've been focusing on history reconstruction, so 3D models, things that were but are not anymore. And I like to bring the past back to life with modern technology. And one of those modern technologies, of course, is Blender, and that's why we're here for. So if I share my screen, then we can show you what we're going to work on. Is my screen visible like this?
Yes, we can see it perfectly.
All right. So what we're going to work on is some little project that I've been working on myself for the past weeks, and that's a system. It's not perfect yet, but a system to dynamically create rigging for ships. I work a lot on ships, and the designing of the ship itself is often quite straightforward when you have like ship plans of old ships and stuff. But when I get to the rigging, it often gets tedious because there are so many different meshes and ropes and shapes, and especially if you want to make it dynamic or posable. So I've been working on a system with geometry nodes to make it a lot quicker. So the idea is that we have one object that spans the actual rope, and then we have two empties that we can dynamically just move to any location, and we can even attach them to an armature. And the rope will adjust itself. Ideally, what I'm currently working on, but it's not perfect yet, is to add multiple ropes through a single block. And that will automatically determine how many ropes needed. But for now, we'll just focus on the basic case of one block and two ropes in between. For that, I set up this little scene with a ship I've modeled before with a simple mast. We can move this around so we can check if our ropes are working correctly after we're finished. Let's hide the ship for now though, and we can see with the blocks that we're going to start with. So this system will work with any kind of block that you model. So I have two basic ones here modeled after 15th century ships, like actual archaeological findings. They're pretty low poly, and that's often because in ships you have many of those, and they're often pretty small. So close up they don't look very good, but that's not the point. So I have two, one that's just the wheel, and the other one that has a ring at the end where the final rope can attach to. And then we have a piece of curve. This one, actually, I should hide the geometry nodes to not confuse anyone. If I hide the thing, it's just a curve and made it in a nice loop. That, like, if you add nodes, you can see it lays on top of each other. In my my own work, there's like multiple versions of this, so I can swap out whatever looks best. So with lots of rope or just a little bit. For now, we're just going to work with this one. And then we have this loop. By the way, if there are questions in the chat, Sterling, you can just shout them through because I don't have the chat on.
I sure will.
Focusing on
Yeah, I'll interrupt and pass them to you. Cheers.
Yeah, great. And then we have this piece, which is actually just a mesh. And the reason for that is that I often make complex versions of these with different variants. This one has a smaller rope wrapped around it to tie it together. But these can be made in all kinds of shapes. They can just be knots, or they can be loops, or hooks, or whatever. And if I hide this, you can see this is where the other rope will attach to. And this hides the seam that will be there. And if I show the origin of the object, you see that the actual origin of the object is around the point where it will hook to the endpoint. And yeah, there's more details, but we'll go into that when we'll get going. So to start off, let's move these to the side a little so they're not in the way. And we'll start with creating two empties that will serve as our endpoints. I'll scale them down a little so they won't look too big. I always try to work on human scales when I work with historical objects, so things work out properly. So I use metric because that's what we live in the country here. Use in the country where I live. So I always try to already get them to the right shape. So if I design objects next to it that don't have any reference, I will still have the correct scale. So we will make two empties where we will tie the rope in between. So we call this one point A and the other one point B. It's called lighting, but what if I call this rope? We'll go work in this one as to not confuse with the things we have set up here. And then we need one other object, and I usually just use a cube because it doesn't really matter, because the geometry will be replaced, so it doesn't really matter what object this is. But let's just move it to the origin with Alt-G. The geometry of this will be replaced, so it can be a cube, it can be a sphere, it can be anything, it doesn't really matter. So to start off, we'll add a geometry node. And we'll go to the geometry nodes top, which you can, if you don't have it, you can add it. If you click the plus here, general on the geometry nodes, it will look a bit different. I organize things around, but this is the basic setup that you get. So we have our 3D view here. And then we have our input and output. I'm going to assume that people watching do know the basics of Blender, and I will try to explain some basics of nodes, but there are a lot of tutorials where you can figure out how nodes work. The basics is that geometry nodes creates a custom modifier in a sense. So whatever all the other modifiers, let's say the ocean modifier, you can now do within geometry nodes. You can completely make your own algorithm for whatever mesh should appear on the place of the old one. So if we have the modifier here, you can see in this one we have the group input that has the geometry input, and what comes out of here is basically the geometry you have in mesh mode here, and then you have the output here, and that's basically what goes in, what you will see once the modifier did its job. So let me pull up the other example because I'm going to use this to get a little peek of what I'm supposed to do. Let me get to the right objects then. Oh wait, this is the shader editor. Sorry. Okay. So we don't actually, we're not going to use the geometry input because we don't actually need any geometry from whatever was in there. So we're just going to get rid of that. What we're going to start with is add some attributes because we need the information from these two blocks, we need to have their location in here. So what we're going to do is we're going to add 2 inputs, and we do that here at group, and we add 2 inputs. We call this point A and point B, and they're going to be objects. So we can set the type of them over here. We put them to objects. Oh, it's a float object. We'll add those. Sadly, they didn't add the eyedropper here yet, so you'll have to search them in the list. I assume that will be added in the future. So we have point A and point B. That means that the information coming out of these now is the information of whatever we filled in here. So in this case, it's point A and point B. But if we, let's say, we duplicate the whole system, you see that these automatically change now to point A001, which are now these duplicate points. So that way we can copy the whole system around and have each row has its own endpoints. One thing we're also going to need, and this is a bit of a workaround for the current nodes where we are, is that we're going to need the reference from the object to itself, because we're going to need the global location, we're going to need the global world coordinates. And currently the only way I figured out to actually get them is to get the orientation of the objects and calculate the reverse of that. So for that, we're going to need a reference to the object itself. And for that, we need one more input. And we're going to call that self. And we're just going to put a reference to the object itself. So if we checked out, it's still called cube. Let's call it rope. I'm going to put rope in here. So we have a reference to ourselves. All right. Then we're going to have the first thing we're going to do is we're going to spawn a line between those two. So for that, we first need to extract the location of these two empties. So for that, we're going to use the object info. We'll tie this one to here, and we'll get an object info for the second one. We'll tie the input to here. And these need to be put on, if I'm correct, on, let's double check. Yeah, they need to be on original. Sometimes you need to put them on relative, but in this time they need to be in original. So that's fine. So that determines if it should calculate the world position or the position relative to the object that we're moving around. From there, we have both these points. No, sorry, I'm incorrect. I double checked. They need to be on relative. Otherwise, they're going to be on world scale and not on the object that we have. I hope it's not too confusing now. So we have these two, and from that, I'm a little lost in my own examples. Oh, here we are. Yep. So from these two, we'll need the locations. So let's drag these over. Let's add a reroute node. And from the other one, we need the location too. Yes, that was it. And then from these two, we're going to add a quadratic Bezier curve. So it will go to curves primitive, and we'll add a quadratic Bezier curve. And quadratic Bezier curve uses 3 points. It uses the start point, the end point, and a point in the middle that determines how much the curve will curve or be straight. So if we add this to the beginning, we add this to the end point, and we'll add this to the geometry output, you'll now see, you'll now see that we'll get a curve, and you can see that it's already curved, and that's because the middle point currently is pointing to an absolute location in the world. But what happens now is that if we move these, that location still stays relative to the global location. So what we actually want is that the middle point of this one automatically gets calculated to be in between those points. To do that, we're going to
Oh, are you still with us, Matthias? Hello. Can anyone hear me? Andrew, Kevin, David?
Hi, Sterling. It's Andrew Buttery here. It's Sunday morning here in Adelaide, Australia. So technically it's still well blended me today, but yes, here in Australia, we have also lost Matthias. In fact, oh no, Matthias is now back.
how long was I gone?
Only about a minute or so. It wasn't too bad, maybe a minute.
Oh, okay. Okay, let me tell what I need to recap.
All right, yeah.
How much do I need to recap?
Okay, and I can see your desktop share. I would rewind maybe a minute and a half and go from there.
Oh, okay. So we need to average. We need the middle point between those two empties, and to get we need to get average of their location. So we're going to get their location. We'll add the two locations together and divide it by 2. That's how you calculate an average. So we use the add the vector math node on add, and then we use a vector math node on scale. We're going to plug this in 2. We're going to multiply it, scale it by 0.5 or divide it by 2. And then we're going to put that in the middle. You see now we are getting a straight line. To make things a little easier, I like to use a lot of groups and name them so that calculations become a little easier to see inside the editor. So for this one, I'll group these together and then go back, and I call this group vector middle. So now we know we can put it like this, and we still know that this one gives the middle of the two vectors, because we get 2 vectors in, we get the middle point out. So we have that. But now to get it properly hanging, we want it to actually to be a bit downwards. So what we can do, if we have for that, what we're going to do is we're going to make this one move down a bit, but there's one important point, and that is that we'll need to make it move down globally and not according to the object. I'm going to show why that's important. So one way we can make it shift down is if we separate math node. If we add the math node, vector math node, we'll add it in here. So, and what we can just do is we can increase or decrease to Z. But the problem now is that if we move our empties, then everything is fine. But if we now move our object itself, and let's say this object is a child of a ship, so it's so that way the rope moves with the ship. If we animate the ship going down waves, we want this object to be attached to the ship. But if we now move the object, let's say the ship goes sideways. Let's add a little cube, and let's. Actually, we do have a ship. That was the whole point of the thing. We can just use this boat. Let's move it up a little so we can see it now. So let's say we parent this rope to this ship, for which annoyingly I don't have We'll parent it to this ship. So object keep transform. And let's say we'll move the ship around. You can now see that the rope is no longer pointing downwards if the ship rocks with the waves. And that's a problem because the gravity is always downwards, even if the ship rocks side to side. So how we can solve that is that's what we need the self for here. So we're going to get, let's minimize those. We're going to get another object info. We'll set self as the object. We're going to use, what we're going to do is we're going to make a vector that's always pointing downwards. But then we're going to rotate that vector by the inverse of the rotation of the object itself. I hope that's not confusing, but what we saw with the ship, if we put the ship back, so let's say the ship is rolling to the right, then you see this thing roll to the right because the object's not here. So we're going to have to move it, rotate it to the left. So we're going to add the inverse of the rotation. So for that, we're going to use a vector math, and we're going to vector rotate. I think it's a different node. Vector rotate, there it is. And for the input vector, for the rotation vector, we're going to use the rotation of the, wait, this needs to be an Euler, that's important. For the rotation vector, we're going to use the rotation of the self object, so of itself. I'm going to put that here. And for the input vector, we're going to use the vector from the vector middle. So we're going to put that as input. And now we're going to invert it. And that's basically going to counter rotate and put it back to its place. Now we're going to put that on add. Let's say this one. Am I doing it correctly? Oop, I'm going to have to do this. This one has to go in here. Oh, wait. This one has to go in here. And this one, we're not taking the original vector. We're actually creating a new vector like this. And that vector we're going to put in here. And if we now increase the z here, or decrease it, so it's downwards. So let's say it's -2, so it's 2 meters hanging. So it's going to be 2 meters down. And we can see now, if we rotate the object, nothing changes. So if we get back the ship and we rotate it, the rope stays in the middle. And if we parent these objects to this as well, so now the empties move with it, then we can see proper movement. So you can see if we rotate the ship down, it's always going to stay hanging straight down because now it's using the global rotation because it counter rotates the local rotation. I hope that explains it clear enough. So that's basically how we're going to do this. But we want to put this not inside the script because then this number will be applied for all ropes because the script will be duplicated among all ropes. So we can make it a setting in here by adding a float. Let's move it down, call this sagging. And let's put it on a float here. And then instead of creating a vector, we need to combine a vector. So we need this one, combine x, y, z. We put that in. And then we're going to put the sagging in the C here. Now we can control the sagging here. Well, if we copy this, make a duplicate, and we'll put the sagging here different, it's not all the same. Well, if we have this node, you can see they do all the ropes at the same time, which is what we don't want. Because we don't want. Okay, so now we have a simple rope. So this is already the basic. You can already do a lot with it because this is basically a curve. So you can apply modifiers to it and all kinds of stuff. But we want it actually to be a rope. So for that, we're going to need to do a little more calculations. But we're going to do one thing first, and that's we're going to attach the blocks. So these things, we're going to attach them to the row here. So for that, we need 2 more inputs. We need, for point A, we need a block for point A block, mesh, and we need a second one of those for point B. Then in point B, we can now input these 2. This one's called block, this one's called block end. So we'll select them here, block end, and now we have these available here as well. So it's gonna get a bit messy in here because I'm not gonna spend too much time on organizing everything. I'm just gonna dump this into a group and I call this group calculate base arc. So this will be base arc. Then let's see what we need more. Yeah, we did that. Yeah, so we have our 2, so we're gonna add another object info. So this one will be for the first block, and this will be for the B block. We have 2 objects, and we're gonna put these as instances because we just wanted to copy paste in here. We don't actually need their mesh data because won't have to edit those. For those 2, we're now going to use this curve. Wait, let's first add a geometry node, join geometry node, so we can make things come together. So if we have a transform, we can change the location of the objects that we spawn here. So we have these objects. If I add them like this here, you can see that they now both spawn at the object origin here, but we need them to be at that location. So for that, we can add the transform to it. And from the transform, we can use a sample curve because we actually need to sample the curve that we have here. We can sample the curve, and from that we get a position and a tangent. The tangent is the direction of the curve at a specific point. We're going to put it on vector. So point 0 is the point of the start of the curve, and 1 is the point at the end of the curve. So that's perfect for what we need. So as curve input, we're of course going to use the curve that we just calculated. So we'll put this in here. And then like this. And then for the first object, we'll put the vector on 1. So we'll put this in here, and then we're going to take the position and we're going to apply that to the translation. And you see that now it's at the position. And this is actually, I have the thing wrong in my head. This is, not confuse ourselves. This is the point A and that's point B. Okay. And then we'll sample the curve again, but this time we're going to sample the end of the curve. So we'll put this on 1. And we need another transform. Put it on here. Let's put this one down here. I'm going to drag things around a bit. So for the other one, position, translation, vector 1, and you see now that one is placed at the location there. But that's not all that we're going to need. One thing we're going to need is the tangents, because we're going to need to make them look in the same direction. So what we do for that is we'll take the tangent and we'll have to invert that. So for that, we'll have a vector math node, vector math, like this. And we're gonna invert that. Let's see, where's the invert? I think we'll just have to scale at -1. It's the same as inverting. Go and invert. Oh, wait, one thing we're gonna do is, because we need to do this twice for 2 objects, what we actually can do is we can we can put it in a group, and then we only need to make one group that applies for both. So let's just take these 2, add them in a group. I'm going to add this group add box, and then instead of this, we're going to take this and put these in. Oh, reverse. Add the curve in there. Add this here. So, but now they're both added at the beginning. So we need one more way to differentiate between the 2. So what we can do is we're going to add a boolean here. I'm going to name this endpoint, so we know if we're talking about the endpoint or not. And then for the second one, we're going to enable that, and for the first one, we're going to not enable that. And then to actually select which point is going to be used for either, whether we need the start or the end, is because we're going to put the boolean into the vector. And the handy thing about Node is that a boolean is true or false, but it can also be interpreted as 0 and 1. And the nice thing about our curve vector is that it also goes from 0 to 1 for the end. So basically, if we put our endpoint into a vector, whenever the boolean is enabled, it will move them to either the beginning or the end. So that we can easily differentiate between what side of the curve we're looking at. And now we only have to make this thing once. So for the rotation, we're going to need a vector that is pointing in the direction of the curve. So for that, we're going to use this sample curve again, but this time we're going to use the tangent, like I said before. And we're going to use the align Euler to vector. This is going to be on X because our objects are pointing in the X direction when they're not rotated. Pivot needs to be on auto. And then for, let's see. For our tangent, we're going to put in the vector. All right. And then we're going to put this into rotation. And you can now see that they are pointing in the direction of the vector. The only problem is one is pointing away from it and the other is pointing to it. And that's because the tangent only points one way. So if we point at the end, we need to reverse it. So for that, we're going to use the scale. So if we put the scale on -1, they're now looking the other way. But now they're both looking the other way. So we're going to use our boolean again. And for that, we're going to use a switch. So this selects between one or the other value. And we're going to put this on float and put on 1 and -1. Let's put this one in here. 1 and -1. Float. Now we'll put this into the scale. It's going to make a vector from it. And now they're actually pointing away. And that's because we have to invert. I don't exactly remember why I did this, but I think it's important. Is that we invert it by the rotation here and not by the scale. Let's just keep it like that, like it was in my example, because that way we won't do anything wrong. To make it a little nicer, we're going to put this on scale on -1. So we're actually inverting the rotation factor here, then aligning it. And now our objects are actually pointing towards the rope. So that's great for that. Now our last thing, let's see, we have 25 minutes left. So we need to be a bit quicker, but I think we're going to make it. We need our rope object around our line here, because right now it's just a simple line and we actually want a rope spawned. So for that, we're going to, because we now have our geometry here, we're going to generate, let's see, I'm searching for my examples on the other screen. So we have to generate a mesh around it. Let's see, yeah, for that we're going to need a curve to mesh. And for the curve, we're going to use our big curve first. Later we'll add 2 curves because we need 2 ropes. But for now, we're going to add 1 curve. We'll put in curve to mesh. And for the curve that goes around it, we actually normally would one important thing I have to say here, you have to use Blender 3.1 for this, because there are some nodes in here that we're going to use that are not available in Blender 3. So that's important, because before, if you want to spawn a circle around the curve, following the curve to make a tube, you would use the circle curve primitive. So if we go to add curve primitives, and you have the curve circle. But the problem is that with this one is that the UVs won't match up correctly. So what we're going to do instead is we're going to use an arc, and we're going to put the arc. We're going to put the resolution on 6 because we don't really need that high of a resolution. The radius, I think I'm using 0.1, so it's 1 centimeter for the rope thickness, or 2 centimeters in total. But we're going to put the sweep angle at 360, so it's going to be a circle, but it's not going to be connected on either side, and that way the rope texture that we're going to put on actually will match. So we'll put this in the profile, and right now you can see we have a mesh around that. All right. Now what we need to get is we need UVs. So first thing we're going to do is we're going to get a texture in. Let's go back to the texturing. I'm going to open to my texture node, and then quickly materials, and then rope. You can create rope yourself with Substance Painter, but there are also a lot of rope textures available. The important thing is that they have a diagonal repeating line, and that they're repeatable textures. That's the most important thing. I'm not going to use PBR for now because it's not really important for the example, but for now we can just do it like this. So we're just going to add to the texture. I'm going to add this in here. I'm going to connect it to the base color, make it all the way rough. So we'll have it connected, but we don't see it yet because the texture is not actually set to this mesh. For that, we need to specifically for here, we need to set the material inside the geometry nodes, because otherwise it won't know which material it uses. And now we can select ropes for here. Is that the one we just made? Yeah, it's the one we just made. Okay. Oh no, it was called material. Ropes is actually one I made before, but let's call this one rope. It's not confusing. Rope. So this is rope texture, but you can see that it's not currently using the UV. It's currently all the way smoothed out, and that's because the UV isn't set. So this can be a bit tricky because to get the UV inside geometry nodes, it's currently a bit messy because we have to use attributes. So first we'll have to add the UV map here. Oh, it's already here, so that's great. There has to be a UV map, and this UV map will be used as an attribute here. And we actually need that as an output because it won't actually ship with the geometry output node. So we'll have to make another output here, and we have to call that UV. And we'll have to put that on a vector and put this on face corner. And if we now go back to our modifier here, we'll have output attributes, and in here we can then select the UV map. So it's a bit confusing that it works this way. I understand why they made it this way, but it's not the most intuitive way. It took me a while to understand like what it actually does. So we'll output a geometry here and then our UV here. And then we set our material here. And then we're going to work backwards because we have our output here for UV, and from there we have to use the attributes, I believe. Yes, capture attribute, we need that. So we need to make our geometry ship through here, and we're going to capture the attribute. We're going to capture a vector from a face corner, because UV is based on the corners of faces, not actually on the vertices, because sometimes multiple faces can have the same vertex but different UV coordinates. So we're going to put this attribute in here, and in here we're going to put our UVs. So we're going to combine a vector, combine X, Y, Z. Put this here. We'll call this combine UV for clarity. And then we'll have to get the coordinates from these two objects, from the curve to mesh and the arc that we made. We're going to have to combine those into the X and Y of the UVs. So we'll again have to use the capture attribute node. And first we're going to use let's see. Yep, we have to use our curve. Put this on float and point. And for the value, we need the spline parameter. Spline parameter, this one. And that's going to say us how far we are along the curve, because that's what we need for the UV. So in this one, we're going to put the length of the curve. And then this actually needs to happen before we do the curve to mesh. I have a feeling it's gonna be a bit confusing for people, but geometry nodes always is a bit confusing. So it actually needs to happen before this. Actually move this out of the way. So we're using our curve. We're capturing the attribute from how far we are along the curve with the spline parameter. And then we're gonna have this attribute. And we'll put this attribute into the Y of the UV. And then for the other coordinates, we're going to use the coordinates from the arc that we created the perimeter around. So we'll put this in here. And we'll put this into the X, I believe. And then this goes into the profile, like this. And in this one, we're going to put the vector. And it's not working yet. What am I forgetting? This is working. UV map. Oh. I can hide this one, so we only have two. Yes. Oh, I add a map node here. Do we actually have? There's nothing appearing yet. Divides by. It's not showing anything. Oh, I'm missing something here. See a profile curve. I'm going to apply the UV. Actually, I'm doing this before. I don't know if that matters, but the set material for me is extra points. It's behind this. So we have curve to mesh, then we apply the UV, and then we apply the geometry, and then we add it to here. And still not working. I think I'm gonna ignore the UV for now. At least we'll have one curve, because I want to show you something else before our time is up. So we're just gonna hide this in the group for now. I'll call this group add curve. Oh, I'm zoomed out a little far. Add curve geometry. I'm going to put this here, and now we're going to delete our basic curve. So here we're adding the geometry of our curve. And we're adding that to the mesh, and then we're also applying the UV, which is not working. But we'll have to do one thing that's more important is that we are going to want to have 2 ropes instead of 1, and they need to be spawning from here instead of the basic point. So for that, I'm going to use a little trick. What I've done in my blocks is that I've added, let me make it visible through and through. If we go to the wireframe mode, you can see that I've added one vertex in the middle of this, here, and right in the middle of the wheel. And then I've added another vertex, which is on the center of where the rope would be around the wheel. I've connected them with an edge, so I can select them both. Actually, I wonder if I'm going to make it too confusing now for 13 minutes that we have left.
12
Let's
minutes.
just make it simple. Let's not focus on this outside vertex. Let's only focus on this inside vertex for now. So we have this at the center point of the wheel, and we'll add it. We are adding it to a vertex group. So if we look here, we have a vertex group. We call it attach point, where it's inside, and we'll assign it. So it's 1. So this point is now an attach point. And because it's only a vertex and only an edge, you won't actually see it if you render this. It might be a little annoying for games, so maybe if you can use this for games later, you might need to edit the mesh or like replace it with one that doesn't have the thing, if that's a problem. But it should be visible when rendering because there's no face attached to it. Because we need that point for reference in our rope simulation. And to get that vertex information here, we also need the vertex information here. So we're going to call this the same. And then just like we had to add the UV to the end here, we're going to have to add the UV to the input here as well. The vertex to the input. So we'll call this attach point. We'll change this to a vector, to a float, because it's a vertex group only has 1 value, not 3. UV. And it will now go back here. We can see that we get attach point with a single value, but we don't want a single value. We actually want an entire group. So if we press this button, we now get an input field. And here we can select attach point as input. All right. So, yes, so if we now have our block, what we now need to do is we need to get the center of that block, and then we need to spawn an arc around it. So for that, we're going to use the arc again, what we have here. And yes, so we're going to use the object info from our block, but this time we need a separate version because we need, for this one, we don't need it to be an instance. So we're going to split this off. We've got the second one where we turn off the instance like this. I have a feeling I'm going to get it over my head here for just this. What do you say, Sterling?
Well, you got 9 minutes left, so whatever you can accomplish in that time.
Well, the point is, the problem here is that in my example, I've actually gotten it a lot more complex because I was adding multiple ropes and stuff.
Right.
So what I maybe can do is just explain the principle for people who want to try this to start off their own thing. I am going to, in the future, I'm going to release this geometry notes as a kind of add-on that people can find on Blender Market probably, or on ArtStation. And then they can get it for themselves and just play around with it and check it out.
Yeah, I think that makes sense.
Yeah. So I think it's better to just explain the principle.
Yeah, that sounds good. And just out of curiosity, Kevin was asking, is that a custom font in your Blender interface?
Yeah, well, I'm just using I think it's Georgia or something. So it's not a fancy font, but it's I like serif fonts. So.
Gotcha. All right. Yeah, hence your logo. That makes a lot of sense.
Yeah, klopt. Yeah.
All right, please continue.
All right, so I'll just explain the basics then. Maybe you can use a little annotations for that. If let's disable the decal plugin so I can actually mesh decal. Let's disable it so I can actually. Hey, how do I get my grease pencil again? I used that too little. Let's see. Oh wait, I can get it here, right? Oh yeah, that's it. Okay, that works. I think not. Oh wait, it's using the 3D cursor. I have to put it here. So the idea is that we have this single point here in our vertex, and what we would do if I would continue here is that we're going to extract this point by selecting it with the we're going to we would select it with the capture attribute node again, and if we put the attach point in here and we take the geometry from this one, this way we'll actually select by vertex group, and we could then use the outputs from this geometry. This will only have the single vertex point in there, so we can then select that vertex. We can then select that vertex point. It's it would have been way too complex if I would be modeling this out now. If you have a look at here, this is just, and this already has groups inside with other stuff. So yeah, you would select the single point and you get that as a base point, and then you would spawn an arc around it. So if we can maybe quickly, just to show what that would look like a little bit, if we use the location transform, if we get our arc here, so our arc should just be start angle -90 to 90, so we get an arc out here. It's not even using the correct location. Anyway, the point is that we'll get an arc around here that is the center at this point, and then it has the distance of the width of this edge. You can see the edge right here. So the arc will be like this. And because we have this arc, we can now use the endpoint selection node. Here, you can use this endpoint selection node to select only the first and the last handle of a curve. So you can see that if we have this arc here, we can now use this point and this point as our start off location of the rope that will spawn all the way next to this one. And we'll basically make a copy of the arc that we spawn here. We'll make 2 copies of it, and we can slightly offset them. So if you can see in my example here, if I only show this rope for a second, you can see in my example here that I have a sagging variation. You can see that I can make one straighter than the other. Basically, if I put this on 0, it's just using a copy of the original curve, but instead of starting it at the middle, it's now starting at the end of these curves. So there's the curve here. If we put this on -90, there's the curve below here. Actually, if I hide this one, yeah, you can now see the curve. So there's a curve here, and then the 2 lines are starting from those points because I select those. And I have a copy of this curve, and I add a variation to it. So if I put this variation, it makes one higher and the other lower. So that way I can make one stretch and the other not, or I can make none of them stretch, go straight. And then we didn't actually end up putting it through the putting it in the ship. But you can see that if I move these points around, that the rope will always be in the middle. I've also added a little wind swing to it. I hope this shows on the stream, but you can see they're swinging in animation. Just a little faster, hide the rest. You can see they actually swing, and I did that just by moving the control point in the center, moving that back and forwards. So it's a very quick way to add a little movement to still hanging ropes. And you can, of course, add more movement by also moving these around with whatever mast you have, or if the ship itself is moving. Let's stop this. And then the second thing is, if you can see, all the examples here. So I have different types of rope coils, different endpoints, different end loops, different ways of tying it off together, all that kind of stuff, different types of blocks with rope or iron. And then I have this endpoint, and for that I'm spawning a little more realistically. So I'm just connecting the rope here to the rope that's already there with a little Bezier segment, so that you can put this down on the deck or on the side of the ship, for example, to have it look more natural, more complex. So quickly, what's in the future for what I'm trying to do here? I want to automatically determine how many ropes are needed, and that automatically spawns the amount of ropes of the blocks you select. So even if you have one with 5 wheels, it will add 10 ropes and that kind of stuff. I will have the wind swing not just be this way, but it will actually take the global wind direction into account. And if it's in the direction of the wind, it won't swing, and only if it's from the side. And ideally, I even want to add a simple collision detection where I can have at a single point, like for example, the edge of the ship, and we'll make a little kink in the rope there so that you can actually have ropes hook around a beam or a mast or whatever. So yeah, there's quite a lot of work to do. And it's already pretty complex, but I hope I've been able to show you guys a little like what I've been working on. And even if if you don't want to try this out yourself, but you do like to have the add-on, once I have it finished, it will be available somewhere. I guess it will be
Hopefully,
when it's there.
Yeah, hopefully a link off of your website, right, Mr. The Rich?
Let's stop the streaming. Where's my button?
All right. Thank you, Matthias. That was amazing. Like as usual. Like love watching your content. So I thank you so much. And again, like Matthias is a regular presenter at World Blender Meetup Days. Actually helped us run it a couple times in prior years. So
made the logo.
Yeah, thank you. Yeah, exactly. So thank you for all your contributions to the event. We really appreciate it.
All right.
All right. Thanks.
Till next year. Goodbye.
So, Scott, are you on the line?
I am. Hello.
All right. Fantastic. So I see Scott is here and Damien is here. So Damien, hopefully you got my note in Discord. We're going to have Scott present for 30 minutes on building Blender add-ons in Rust, and then the show's all yours.
Cool.
So,
okay, great.
Okay,
right.
fantastic. All right, Scott. So with that, why don't you do a desktop share and introduce yourself, introduce your topic, and take it away. Matthias, can I get you to stop screen sharing? Let's see, hold on. I tell you what, Scott, see if you can screen share over the top. Let's try that.
Let's see what happens.
All right. If not, I'm sure I
screen
can
share. Do you want to continue? Yep. Okay. Looks like I may be able to screen share. Sweet. Okay, you can see my screen.
There we go. Perfect. All yours.
Oh, sweet. Okay. So yeah, so my name is Scott Wilson. I'm a pipeline technical director at a studio in Vancouver, Canada. I'm also the organizer behind the Rust working group at the Academy Software Foundation. And finally, I'm also the organizer of the Vancouver Blender user group. So that's how this all kind of connects, at least. So hi, welcome to my presentation on creating a Blender plugin in Rust. I'll try to go extremely quick because the last time I did this took 40 minutes. So I'll see if I can make it in less. All right, so here's kind of the case that we have. You have to create a tool for an artist, and you build it all in Python. You test it, it works, you're happy. Yeah. So you're saying, okay, let's send it over to my artist friend. They receive the tool, they're testing it, and they report back that's unusably slow, possibly because you're testing on a really simple case, and then they're like, okay, let's test this on production asset, and suddenly this is taking forever. So there's several possible causes of slowness. One of them is like the algorithm. Try that again. The algorithms that you are using could be inefficient. You could potentially like do more caching, store more things in memory rather than kind of compute on the fly. And also interacting with a Blender scene graph may not be kind of efficient for your use case. And just in general, Python is slow. So just as an example, I created a thing where I'm calculating the Fibonacci sequence. And in Python, it took about 1.5 milliseconds. So that seems pretty fast. But I did the same thing in Rust, and it's 19 microseconds, which is 1/1000th of a millisecond. So extremely fast. So yeah, so why Rust, and why not say C and C++? I'm just going to quickly. There we are. Now, a little less noises in my head. Sorry about that. So yeah, so why Rust? So one, it's very fast. It's about as fast as C and C++, sometimes faster, sometimes a bit slower. It's what's called memory safe. So it can prevent random crashes due to trying to access memory that it shouldn't access. So this is also something that Python has too. It also supports multi-threading, unlike say Python. And it makes it really easy to write multi-threaded code due to the rules that the compiler kind of sets forth to kind of say, you have to follow these rules, otherwise it's not going to compile. It has Python support through a package called Pyo3. It has a great build tool called Cargo, which is kind of your Swiss Army knife of the Rust world. It does testing, compiling, dependency management, and you can add other plugins too to also say, for example, add on more of these crates, which are these packages in Rust all through the command line. So super great tool. And there's a huge list of libraries that's growing every day. And you can access it through crates.io, which is similar to the Python package index, PyPy. So why wouldn't you use C or C++? So they're memory unsafe. So it's easier to trigger what are known as foot guns. And so you can try to access memory that you shouldn't be able to access. So some kind of terms, double free, use after free, accessing, erase out of bounds, etc. So hypothetically, in C, if you don't create the checks yourself, if you have a list of 10 items and you say, okay, what's the 20th item? C is going to give you a 20th item, but it's going to be not what you're expecting. Building non-trivial packages is not easy. So you may need to compile dependencies of dependencies of dependencies, set up CMake, which isn't always the easiest thing to do, or whichever build system the package uses. And there's about a billion kind of ways you can build a package. Multi-threading is hard due to the memory safety issues that are kind of outlined above. And yeah, so let's quickly head over to the demo. Okay, so this is just a quick kind of skeleton of a project, just to kind of start ourselves off. There's a few things that I'm using, such as virtual environments inside of Python. I have some other plugins installed. I'm just not going to go over right now, just to kind of keep things going pretty quickly. So right now, what I'm going to do is I'm going to create a smooth mesh operator. I'm going to start with doing it in Python and then do it in Rust. If I have time, I'm going to do some more kind of funky things in Rust to kind of prove how fun things can really get. So in Python, so I'm going to need to do a few things. And I'm going to be doing a lot of copying and pasting just to make things faster. So first thing is I'm going to create a float property, because what I want to do is I want to control how much I'm going to smooth the mesh. So we have our pull method, which is just going to let us use this operator if the active object is a mesh and if we're editing the mesh. There's also an invoke, which right now is just calling execute, and for the Python stuff, it's not needed. Also, you may see that I make heavy use of types, or the type hinting in Python, just because I absolutely love types. The more I program, the more I appreciate the fact that static typing exists. Okay, so let's start with, I'm going to copy and paste the function, just kind of explain what I've just copied and pasted. So we have the smooth mesh method. So what I'm doing is I'm kind of defining some types. This isn't really needed, but it's only really needed to kind of make my IDE, Visual Studio Code, and the Python support a little bit happier. So I'm just kind of casting the amount to a float, which already should be at that point. Then I'm going through every single vertex, and I'm copying the position information of those vertices. And then I'm going through all the edges that are connected to the vertex. As you can see right now, yeah, so I'm going through every single edge connected to the vertex, and for all those edges, go through all the vertices. And if the vertex index is this one, so if I'm going to be trying to access the same vertex, then I'm just skipping over it. And what I'm going to do is I'm just going to add the position, and then I just add to my count. So essentially what I'm doing is I'm going to average all the point positions of the points that are connected to a specific point. So that's this average bit right here. And then finally, I have a weighted point. So basically what it's doing is it's doing what's called a linear interpolation between what was the current point position and what I want to smooth to. And I'm gonna store this into another list because what I want to do is make sure that I'm not modifying any of the vertices until the very last step. Otherwise, it's not going to smooth as expected. Yeah, so I do all the smoothing, put it into another list of vertices or positions. And then after that, I go through all the vertices and update their position and update their normal. So that was, oh, and there's one thing that I forgot to mention. So this execute method, like essentially all I'm going to be doing in this is the execute is going to create a B mesh from the active object. It's going to run my smooth mesh, and then finally it's going to update the Blender mesh. So then you can actually see the smoothing that's done. Because if you don't have that, you're not going to update anything. So let's build Blender or do the build and start. I'm not actually compiling Blender. Give this a moment, wait for Blender to open. And I'm just going to test this on the infamous Suzanne. So since I don't have this in any of the menus, I'm just doing the F3 menu and doing smooth mesh. And here we have it, our awesome smooth mesh. And you can see that this runs pretty quickly, but if I were to add more subdivisions and more vertices, it's going to slow down pretty quickly. So let's go ahead and close Blender. So that's doing everything in Python, which is totally valid if it works. And if everyone's happy, then you can totally do that. But let's go on to the next step. So we need to do a bit of work to get things working with Rust. There we are. Okay, so first thing we need to do is we need to set up the Rust environment. And it's literally as easy as doing cargo init lib. So essentially what I'm doing is, since I'm in the folder or in this project folder, I'm just turning this into a Rust project. And as you can see, it's added this cargo.toml and this src folder. So we're going to go into this cargo and just going to do a lot of copy and pasting. And there's a few things that I need to point out. So thing number one is, let's start from the bottom. So we have this PyO3 package I talked about, this PyO3 crate. So this is what gives me access to Python support. And this end algebra crate gives me access to a bunch of math operations and what have you. So then there's this lib, and this is really needed for when you're doing Python stuff. And you need to make sure that this, like this name is actually extremely important, and also this. So this one basically, when the Python library gets compiled, it's going to assume that it needs to be called smooth mesh. And this just tells Rust that when you compile as a C library. Otherwise, anything that depends on C can't access this library. It's all kind of within the Rust ecosystem. So I need to do a few things on the Python side. So thing number one is I'm just going to comment that all out and copy and paste this thing here. And also from .import smooth mesh. And that bit will make sense in a bit. So just as a quick thing, so what's going to happen is I'm going to pass in my mesh. So we have this underscore mesh, which hasn't been defined yet. I'm going to pass it into my smooth function. So this will all be within Rust, and I'll show that in a little bit. And then I need to pull that information from Rust. So I'm getting all the point positions. And then I'm going ahead and modifying the mesh. But before that, what I need to do is I need to be able to copy everything from Blender and put it into my Rust plugin. Otherwise, I can't do anything. And you can do that by doing that within the invoke. You could do it in either the invoke or the executor, because the invoke happens as soon as you start the tool, and the execute happens every time that you kind of, like say, for example, if you change this float property from like 0.5 to 0.6, then it's going to run everything within your execute method. So just to make things a little bit more efficient, I'm doing it at an invoke, so as soon as the tool runs. So you may notice that a lot of this code kind of looks pretty much the same as before, or at least very similar. I'm just going through all the vertices. I'm going through all the edges and all the vertices connected to the edges, storing their indexes. So then I have this vertex type that I've defined in Rust, and it's going to store, what is this current point position, which is defined up here, and also all the indexes of all the vertices that are directly connected to it. And then after that, what I do is I create a mesh object, and then I pass in all the vertices. So this is like kind of like an incomplete mesh. It's only storing the information that I need to do my mesh smoothing. And that should be more or less it on the Python side. So let's head over to Rust. So if we get to my lib.rs, it automatically comes in with this testing to just say, hey, here's a test. They can prove that things work. And I'm just going to go chunk by chunk and kind of explain what's happening as I go. So what I'm doing is kind of the same as like, if you're to do this in Python, it'll look something like from py03.prelude import star, which if you're a Python developer, you may be like, oh, that doesn't seem right. It seems like you're kind of doing some ugly things. And that's kind of right. And also it's kind of right in Rust too. But by convention, anything in Prelude is kind of more or less supposed to be kind of safe to just add to your namespace without kind of causing weird issues. And I know that I'm probably going like a mile a minute, so hopefully I may have some time to kind of answer some questions. So the first thing I'm going to do is I'm going to find what a vertex is. So the position is a point, so that's using that in algebra. And the connections I'm defining as what Python will call a list of use-size integers. So I won't go kind of too much into detail what a use-size is, but it's basically an integer that has some special properties. So once I have my vertex, I'm actually defining all the functions, and this py class and py method, and also this is kind of try to think of what I'm trying to say, like a macro tagging thing inside of Rust, where it actually implements more functionality on top of this struct. So what's happened now is I've kind of said, okay, take this struct in Rust and turn it into a class in Python, or at least make it look like a class. So this new thing here, by convention, the new method in Rust is kind of like your constructor in Python. So what this allows for is in Rust, it will look like, say, vertex new, but in Python, it will look like vertex and yeah, so that's kind of how that syntax looks a little bit different. Yeah. Okay, so continuing on. So I've defined what a vertex is. I need to define what a mesh is. And basically defining a mesh is more or less the same as defining a vertex. So I'm not going to go into a huge amount of details with that. But the one thing I should say is we have this py result, and rather than like raising an exception in Rust, you usually return these result objects. And this is just kind of like a kind of like a wraparound result. So if there is an error, then it's going to kind of flag, hey, there's an error. And that's kind of the Rusty way of doing things. So then let's look at the smooth function. So I'm just going to take a second to just kind of show the code for a moment. So I take a reference to the mesh, and I have the amount that I'm going to smooth. And if you look at the code here, you may see it's actually kind of similar to what we did in Python before. So if you're looking at the previous recording, you may want to kind of pause here, look at the other code and just kind of do a compare and contrast, because for the most part, this is actually pretty much the same as what you've seen before. And basically at the end of it, what I'm doing is I'm taking the mesh that I've passed in, I'm going to pass in a new mesh, which has all the blurred, or not blurred, smooth vertices. And finally, so this actually, this function, the name of the function actually has to be smooth mesh in this case, because this name and this name have to match, otherwise the library is not going to be happy. So then I'm going to run a build script that I made. So kind of talk about how, you know, cargo build. So once again, cargo, the Swiss Army knife, I can build as release, so do all the optimizations possible. And then by default, when Rust compiles, it's going to compile under lib smooth mesh, but we don't want that. We want it to be called smooth mesh. Once again, otherwise the library is not going to be happy. And I'm also just moving that smooth mesh from the target folder here, and that gets generated, and it's going to be stored right into the root of the folder. So there we are, smooth.mesh.so, which is perfect for Linux. So let's do build and start once again. So I'm going to test this on Suzanne, just to kind of prove that this works. So now we have Suzanne smoothing, and the code that actually smooths her is in Rust. So that's kind of the cool bit, but I have a bit of time, so I'm going to show kind of the next step. Okay, so let's say that this is not fast enough, that your artist friend has come back to you and said, hey, I need this done even faster. Because right now, by default, that's actually not using any sort of threading at all. This is all single threaded. So what I'm going to do is I'm going to do a tiny bit of a refactoring of the code, because for this, I could have the smooth function operate through like a for loop or a bunch of for loops. But for the sake of what I need to do, I can just kind of completely change how that looks. So let's do this. And essentially what I'm doing is, I think if you've done any sort of like functional programming, you may see this, where it's kind of like you're training methods on methods on methods. So I'm taking my vertices, I'm saying, okay, iterate over all my vertices, and then map that. So then I basically pass in a function that takes a single vertex, does my operations on them, and then it's going to pass out, you know, that this new vertex is generated. And then finally, we collect it. So it's going to convert this in from an iterator into a vector. And then I pass the vector into this new mesh. So once again, this is probably a good moment to kind of pause and take a quick look at the code if you're looking at a recording, because what we have here and what we had with the for loop are going to be more or less the same. And just to kind of prove that's more or less the same, I'm going to go ahead and compile this. So compiled, build for Blender. Let's bring out Suzanne again. Okay, so we look at her, she's smoothing as before, we're in a good spot. So functionally, nothing's happened. But here's the cool bit. So Rust has a library called Rayon. And what Rayon does is it basically lets you do multi-threading on anything that kind of looks like an array. So I add an rayon, which is cool. And then all I need to do is let me double check. Yeah. So the only thing I need to do is I need to take this iterator method that's here and rename it to pair iter. And oh, I forgot. I need to add a new preload at the top. So we need to add this rayon prelude, and as you can see, these two shouldn't conflict with each other. And the squiggly lines under there are resolved. So I'm going to go ahead and compile this one more time. And as you can see, there's more dependencies I need to compile. Go hop back into Blender. And let's see, monkey. So, and now this is going to be smoothing in a multi-threaded way, which, you know, according to the other ways too, like you probably won't notice a difference on something as simple as Suzanne. But if you're to subdivider, or if you're to do even more vertices, then at that point, that's going to be noticeable. So that's basically the end of the demo. So kind of what can we do from here? Let's go back into slideshow, presenter view. So where can we go from here? So right now there's still kind of a bunch of things that are happening where we're kind of taking objects, kind of do stuff with them in Python, converting it to Rust, and then converting back to Python. So potentially one thing that we could do is like make that Python code even smaller, and you know, as much as possible, like, you know, connect to like the raw XC structs inside of Blender into Rust. So right now all the enormous calculations are being done on Blender, and I don't know if that's being done multi-threaded. So potentially, you know, that's something that could be done inside of Rust with the multi-threading to kind of speed things up. And, you know, there may be some further improvements that we could do to the structures to kind of reduce like creating new objects and stuff in memory, which like allocations are known to be kind of the slow thing. And yeah, that's basically the end of my presentation. So if we have time for questions, I'll be more than happy to answer. But if I don't have time, then on with the show.
Thank you, Scott. So you finished exactly on time with just like 2 minutes to spare. We don't have a lot of questions in the Teams chat. Oh, wait, we have a question here. So first off, Michael Prostka says CMake is horrible. It sounded like he was agreeing. But secondarily, it says, if we allocate memory inside a Rust function, what happens to it when the function ends and we return to Python?
So if you do it all through the PyO3, what should happen is you're kind of moving ownership from the Rust to Python, and the PyO3 is going to kind of manage, you know, that kind of transition. But otherwise, you like if you're to go like say from Rust to C, you may have to actually tell Rust, it's like, hey, by the way, forget that this memory exists, and let something else kind of take care of it. And then you're responsible to kind of go back into Rust and say, oh, here's this object that I want you to delete.
Gotcha. Okay. So I think that's it for the questions, and we're just about out of time here. How do people reach you on social media or find additional information, I guess? Is it just the user group URL, or do you have a personal page?
There's a few ways you can catch me. If you go to the Academy Software Foundation, and especially the Academy Software Foundation Slack, I'm on there. If you want to do me, or if you want to talk to me on social media, I'm proper squid on most things. so Twitter and what have you. But I'm also Scott-Wilson on GitHub. So yeah.
Gotcha. Okay. If you want to drop those into the Discord, we'll be able to share them for you. The URLs get stripped unless we send them out. So if you wanted anything to share with people, please send it there. But thank you, Scott. We really appreciate it. And I was going back through one of my old LA Blender user group meetings from last November and spotted you on there.
Oh yeah.
So thanks for being part of the community. Really appreciate it.
Yeah, no worries. Thanks for having me.
Awesome, Scott. Thanks.
Bye.
And so with that, I'm going to transition to our next presenter, who's Damien Rohrbach. Damien, are you on the line?
Yes, hi.
Hi, Damien.
Here,
so thank you. Thank you for your flexibility and patience today.
Everybody's patience.
Yeah, I'm guessing you're probably going to share desktop, correct? Why don't you?
Yes, let's.
Yeah, why don't you go ahead and do that? And then once you've shared desktop, if you could just introduce yourself to the group, introduce your topic, and then take it away. You have the next 60 minutes.
All right, so my name is Damien Rohrbach. My artist name now is the Jewelry Rockstar. So, well, the subject of the presentation is jewelry design with Blender. And today, well, I'm going to show you how I modeled this ring in Blender, and I'm going to do it with Blender 3.2. It's going to be like a full tutorial. So let's start easy. Let's go add a mesh circle, front view here, 120 vertices, size is going to be 9.1. So that's like a normal finger size. You can find the ring chart sizes on the internet, obviously. And we're going to, in edit mode, let's make this a solid. I'm going to make an extrusion, E, this way. Now A to select everything, mesh, normal, outside, just to check that it's properly oriented. Okay, so that's just for the size of the creation. Now the stones I'm going to append from my library. Let's curse the disk. Okay, gemstones are here, and the new one, this is the new one. Okay, so I'm going to bring in two stones. Object, so it's the pear shape, and a small diamond. So append. Okay, so obviously they're hidden right there. Okay, let's start with the pear. I'm going to make it 10 times bigger. Okay, so about the dimensions in Blender, I get this question a lot, and many people on Facebook or Blender artists and everywhere making 3D printing, because the designs I make are for 3D printing mostly. In Blender, we have meters. So my stone now is 6.4 meters big, which is like obviously not the real size, but because there's 1,000 difference, if we export this as an STL, it comes out at 6.4 millimeters. It always works. I don't know. It's very easy with Blender to get things real size for 3D printing, but well, okay. So now that's my stone. I'm going to move it right there. G, let's start with the mirror here on the y-axis. So let's make a Control A, all transforms. Well, obviously the position we'll see Control A a bit later. Okay, now the small diamond, let's bring it up here. Size 125. I'm going to copy and paste the scale right here. And let's bring it to the side. So this is just a reference for the setting I'm going to make. So this is the reference for the design, anything. If you just cut the stream now. Okay, so from here, I'm going to add a plane. So the plane, I'm going to set around here. Okay, let's move it a bit to the left. Now, edit mode, let's erase these two guys. Alt-Z for X-ray mode, we're going to have the shape or something similar here. Now I'm just going to extrude this, follow the shape of the stone, and I'm going to start modeling the metal structure. So I trained this only once for today's session. I do use Blender every day for jewelry design, jewelry render animation. Okay, so from here, we're going to take A and extrude just here, and then scale, scale. And I've put the stone as reference because I need this part to be a bit bigger, a bit wider than the small diamond here. Something like this should be fine. All right. Now, what we want to use is the shrink wrap modifier or mirror first. Let's make the mirror. So let's do a Control-A, all transforms. And this is pretty good for now, even on the y-axis. Okay, so we are too close. We're going to move everybody a bit further away right here. Okay, same for the stone. So you can do that in edit mode when you already have the mirror turned on and you don't want to set everything back to 0. You just do that in edit mode. I don't forget to save the file. This one is going to be live. World Blender Meetup Day. Okay, here we are. All right, so far nothing great, but now with the shrink wrap modifier, we're going to go to the nearest surface, and the target is the cylinder here. I know, but not for the stone. That was so funny. Sorry, it's for this. Okay, so shrink wrap, here it is. And target is this. Okay, so now it's starting to take the shape of the finger because that's basically one of the main problems with jewelry design, the finger. Okay, so we have this clipping. We're going to turn the clipping on the mirror. And let's go here now. I'm going to adjust just by moving the clipping here, this part. And something important that I'm going to add also, the solidify modifier. We're going to go in +1 in thickness. We'll see about that, maybe 0.7. That's pretty good. Okay. And also we're going to, okay, so now obviously we're going to use the subdivision modifier, but if I do that now, you can see that my structure is shrinking, which is something I don't want right now. So before the subdivision, I'm going to use a bevel modifier and maybe a 0.2. I'm sure. Mode and 2 seconds. Okay. And now generally the bevel modifier, what it does is it makes the edges sharper, which is what I want for this design. All right. So I'm going to keep it like this. And we're going to go at level 2 or 3 for the subdivision. Let's go at 3. All right, so that's pretty smooth. But now I need to adjust because of the shrink wrap. I need to adjust to the real size. So let's go back to edit mode. And this is already a huge speed advantage using those modifiers because I only have to move those vertices and I have a lot of control over the entire design. Okay, so here I need basically all this line to be more to the left here. So let's start with that because the width of that part of the design, which is going to receive the stones, is the most important part. maybe not that much. Maybe here, let's go back. Okay, I'm going to bring the stone a bit lower just to, okay, that's way enough. And obviously, because in jewelry, we need to think about the weight, the ergonomy. Well, the weight, that's one thing, because if the jewel is too heavy, you'll have a lot of troubles using it. And also the cost of the jewel is going to rise very fast. You know that the gold, because all the war going on, is constantly rising, which is not very nice for jewelers and their customers. Okay, anyways, so the weight must be very low, the lowest as possible, to make an amazing jewel, and also then the ergonomy. Okay, so you want very slim structures, but appealing structures. And Blender is just amazing to do that. Okay, so we're pretty good for the size here. So I'm just going to adapt the rest. Okay. And this is pretty nice. Maybe I'll have some smaller stones going to the tip. We'll see about that. Okay, but this is just the lower level of the setting of the pear shape stone. And okay, this is great. This is good. Okay, the shape is pretty nice. And okay. So this is the first part of this structure. Okay, now what I'm going to do from that, I'm going to Shift D, copy the structure. Now the shrink wrap has an amazing option, which is the offset. So I'm going to move it about 1 millimeter, 2, 1.5. And this allows me to create the second level, which is the one that it's going to receive the stones. Okay, and I'm going to make this part thicker, maybe 1.3, 2. And okay, also I'm going to move this a bit here. Let's center this. Yes, let's go to object, to surface center here and to body center. Okay, just so it looks good during the presentation. And also I'm going to remove the floor. It's a bit nicer to the eyes. All right. Okay, so now I have the second level, and this is all thanks to the modifiers I'm using. Okay, now we're going to make actually the technically hardest part of this, and that's why we're here. The settings with the prongs and that part. Okay, so to do that, there are a few tricks, obviously. Okay, the stone I can put almost anywhere, but the trick here, the stones, they need cutters. They always need cutters for the light, for the position of the stone, but above all for the light, so the light gets to the stone. Okay, so here I'm going to do a Shift S, cursor to the stone. So when I add my circle, it's going to be smaller too, maybe. Okay, so the stone. Okay. So I just added a circle, and I'm going to create the cutter. Here, edit mode, extrude. That's the head of the cutter. F. We're going to close it. Side view, Alt Z, Alt A, B. Select this. Go down. No, sorry. We need to extrude first. Extrude on the Z axis. It comes around here. It becomes smaller to follow the cone of the pavilion of the gemstone. Extrusion on the Z axis here. That's the central part of the cutter. And then generally the bottom part, again, extrusion gets a bit bigger. And again, that's to remove even the slightest metal we can. Extrude again, I'm going to make it long enough. Okay, and F, just close it. A, mesh normals outside. All right, okay, so this is the cutter. Let's call it cutter. Okay, now we need to deal, the diamond already comes with materials that I won't use, but the cutter, let's set a cutter material, just any material with any name for the cutter. Because I'm going to join the cutter to the gemstone, Control J. Here we are. So now the gemstone comes directly with the cutter. That's obviously a professional trick, because now I'm going to start distributing the stones around the pier. Okay, around the pier shape. Okay. So to do the distribution, I'm going to turn. Okay, so the first stone is at the tip. This one I'm going to put by hand here. Now the height, it needs to be okay at this level, because then I'm going to create the prongs and borders. Sometimes it needs to be lower than the surface, but in this design, and that's obviously one of the main advantages when you're the jewelry designer of that same design, and at the same time the jeweler who is going to manufacture the design, you have a lot of advantages. So I always tell people that before becoming jewelry designers, there are way too many around the world. Anybody is a jewelry designer. Just everybody knows that Brad Pitt, Angelina Jolie, Britney Spears, whoever you can name from the entertainment world is a jewelry designer, basically, because they're famous and they team up with famous brands and they create a jewelry collection. Obviously, it's just a marketing joke, and that's not the way it goes. So first, become a jeweler, because the world needs jewelers. The world needs people manufacturing the jewels. Actually, the world does not need that many jewelry designers. And yes, it's sad. It's really sad because, well, people would dream to be the other way around, obviously. But believe me, I've been doing this for 20 years and teaching for almost 20 years. So believe me, become jewelers and then design. That's why we're here designing like this, because I manufacture the jewels. Okay, so from there, the stone is a bit higher. All right, so that's the easy one. But from there, we're going to turn on the volume and alien rotation here, affect rotate, and go to the center. This one should be good. Okay, so you turn the snap on, and with the snap, you can start copying this Shift D. And the stone should be, is it? No, it's not. Okay, so let's go to face and let's go to closest. Let's see. Sometimes, okay, Shift D. Okay, this is working right, almost as it should. And let's go to medium then. Okay, Shift D. Is it coming along? Okay, this is perfect. Okay. So now I'm going to turn on the mirrors at once on the XY. Okay, let's do Control A, all transforms. And is it going to work directly with the median? I think yes. Okay, Shift D. And no, it's not. So I need to keep. Okay, so let's not turn the mirror on now. So let's Shift D. Let's move forward faster, because obviously 1 hour to model a ring like this is pretty fast. Generally, it takes a couple of hours when you're trained. Okay, this is perfect. It's following the surface of my belt. Okay, Shift D. And okay, this one's too close. You can't always see perfectly from the top because of the cutter, but believe me, you need the cutter right here at once. Okay, and here, let's see if we are going to have, okay. So I'm going to bring this one here. And let's bring, okay. So we have a little more space between the stones, that's all right. And many people always ask me why I'm not using add-ons. Obviously, people who follow my channel stopped asking because they understood after all these years. I'm not very fond of automatization because I do a lot of custom designs. That's basically now my main everyday work is I'm a jewelry modeler, 3D modeler, mainly for jewelry clients, even if I also do some logos and things that are not always jewelry related, but that's very few of what I'm asked to do. So I don't like automatization. I don't believe that much in calculus for jewelry. There's a type of jewelry that has been overdone over any generation, which is the geometric type of jewelry, which is a generative, well, because you can design, obviously, jewelry, very pretty jewelry using math, algorithm, and all that. But that's one of the exceptions. But otherwise, we don't really need that much we don't need that much to use, well, tools to make the settings. Obviously not on advanced design with some hundreds and thousands of stone. Yes, I am going to use another software than Blender. Okay, so here we're good. So now let's take all these guys, Control J. Now, well, obviously I could have turned on the mirror before, in fact, but it's a bit faster here without, okay, Z-axis sometimes. Okay, and is that all right? This is pretty nice. Okay, so we are going to do the same for this guy. Mirror from the cylinder here. Okay, here we go. And on the y-axis, now on the z-axis. Okay, that's because of the rotation on the cylinder. Okay, we have all that. So let's make Alt-C. Everybody becomes a mesh, and let's join all the gemstones and cutter, Control J. Okay, now let's go to edit mode. And now it's why it's important to have, let's do an Alt-A to deselect everybody, Alt-Z. Okay, why did I set the materials prior to making all this? Because that's the practice trick. Now I have the cutter materials, and I can simply select all the cutters, do a P selection to extract the cutters, and we're good because the cutters have exactly the position of each gemstone, okay? So that's why I always say that the brain is the best add-on, because these small tricks make that Blender is really, really good at jewelry design. And now what do we need? We need the Boolean, okay, on this guy, Boolean. And even the Boolean modifier has become better. It's better each day with the fast solver. Works almost all the time for what we have to do here. So here I'm going to hide the gemstones, and we can see we have, yes, we have a perfect cut, a perfect Boolean. And this is just great. Okay, so we have, okay, these guys are the cutters. Obviously, I'm going to hide them. We don't need to see them anymore. Okay, and the gemstones. Now we can bring the gemstones a bit higher so they don't touch, or they're not too close to the metal. That's more important for the render to get very nice refractions and dispersions in the diamonds. Okay. And what else? Okay, so now another little trick. I need some borders, and I'm going to copy this, Shift D on the Z-axis. Don't forget to remove the snap. Did I make the copy? Yes. G on what axis? Come on. No, let's make a, okay. So I made the copy of the base shape, but I'm going to remove the modifiers, the solidify also. The mirror should be okay. I still have the shrink. Okay, no shrink wrap. I know I want the shrink wrap. So let's do an Alt C. Let's go to edit mode, Alt A, and I'm going to remove one side here. Okay, so I have the basic shape and I just want the borders to make a bevel. Okay, let's see. So I'm going to copy it again. And what I'm going to do, just need the outer rim and the inner rim. So Alt Z, Alt A, C. So I'm going to remove this part. And I'm going to show you what I'm going to do just for the edge, for the bevel, so to match exactly the shape. So this is a mesh, but let's go to Object, Convert to Curve. And now I can use the geometry on the curve. Obviously, make it round at 0.3. It's a bit too big. 0.25 resolution, something like 10. Okay, it's a bit not smooth, obviously, but here we're going to use the subdivision surface 3 times. Okay, and that's how you get the perfect edge. So because of the shrink wrap height, the shape might change, but that's okay because it's only on the x-axis, like here, and I'm going to make it a bit thinner at 0.2. Okay, this 0.22. Okay, that's pretty nice. I'm still going to make it lower. I don't want it to touch the stone, so let's make an SZ to adapt a bit more to the edges of the stones. SX. Okay, this is pretty nice. I just want to see if I'm touching the stones. No, that's close. Okay, this one is a bit. I'm going to move this one a bit here. Obviously, jewelry design is very precise, especially precise. Some people don't have the patience to be that precise, and well, you can always train your patience. All right, now I need the inside. So with the control key, I'm going to remove, let's see. Let's remove the outside. I also want an inner bevel here, delete vertices. Okay, same process here. This is a mesh to a curve, convert to curve. Let's go to round 0.22, same size, resolution 10, and we need some subdivisions. 3, did I go to 3 on that one? Yes. So, okay, G, Z. Let's have a look at how it works here. SX to get here, get closer to the stone. That's pretty nice. Okay, I want to have a look at the resolution here, maybe 24, and it doesn't change anything in this case. But let's have a look at if I can get a sharper. Yes, I can get, but it changes the position a bit too much. I'm going to leave it like that. Let's make an SY. Okay, that's pretty nice to fill the gap. And here, let's make an SY to reach the pointy point. Are we good? Yeah, we're pretty good. Okay, so now the prongs, basically. Here, I'm going to move a bit. But you know what? I moved one side, not the other one. Okay, so when you forget that you need a mirror, and we're going to go back to where we were here. I just forgot to that the mirror is already applied. Okay, so what do I want? This stone is a bit too close to this. The position of the cutter is all right. I obviously already made the cuts. I could move it if I really have to, but because of the angle, I can slightly move gemstones here. Okay, so now let's do an LP, and we're going to make the mirror again to match the same position on each sides from the cylinder on the z-axis on C, and obviously this needs a mirror on the Z only. Here Alt C, Shift Control J. Okay, so now the prongs. So yet again, in many software, many software, even the most expensive softwares, we have, that's generally why you would buy a specialized software for jewelry design, to have a tool to create the prongs for you, okay? But I'm going to make an example here because I do that a lot in Blender. Here's what 0.7 should be right. So this is the first prong here. In this design, if you look at the design, you won't necessarily notice that the prongs, in fact, are not changing angle based on the shape of the jewel. Generally, they would. And well, if you look at the image, you don't even notice that the prongs are straight. And I'm going to show that this is a decision that the jeweler or the designer makes, and that sometimes it makes the manufacturing or the design of the jewel easier and faster. And it's going to be the case now. It's going to make the design faster because I won't have to turn on the snap. Just make the object smooth. Okay, so this is a prong. Let's call it prong. Here. And let's make a Shift D here. Okay, here I am going to, before I copy it, okay, let's turn on the mirror at once. It's going to be a lot faster and prettier to have the mirror on each side. And at once, I need this friend to be a bit here. Okay, sometimes you see some details. All right, this is pretty good here. Okay, so the prongs are right there on each side. Let's make these guys as mirror from the cylinder on Z here, and this guy too, mirror to have the same states of the jewel on each side. Okay, this is good. Okay, so here I'm just going to copy them, and I'm going to do this by hand. And you're going to see that it's not that slow, it's fast. So here I just need to move them on the Z-axis to be at the correct level and follow the shape, but not the angle. And this is peculiar to this design, but because I designed this part like this. Okay, so it's going to be easier to do this task that normally there you would use an automated tool which calculate the prongs for the line of gemstones, but here we're just going to do this by hand, and there are not that many. And I already made quite a few. I'm still going to make a lot more tutorials using Blender, showing how to do this on very complex meshes, like the monkey, by example. I did the Suzanne Pavé last year, I guess. Hey, obviously, it's for fun. I know, actually, it was 2 years ago because I made it for the Meetup day 2 years ago. All right. So here, just on the Z-axis, and the position for the prongs to really set the gemstone is perfect. The prong must always overlap the gemstone a bit, like 2 decimals in real life, to be able to set the gemstone properly into place and tightly. Okay, so, and obviously, actually, you might think that an automated tool would be faster, but you would get a lot of mistakes from the tool because this shape changes angle too much, and the software would change the angle of the prong each time for each gemstone. And you can only get this design, this aesthetic by hand. It sounds funny that even after that many decades of evolutions with 3D softwares, there still are operations for us designers that come out better done by hand in the digital scape, in the 3D world. But, well, that's something you learn by designing a lot and manufacturing a lot. And you understand that no matter how powerful is your software. So obviously the geometry knows I already did 1.5 videos. I am going to use the geometry nodes for jewelry design, but it's more like for research than really a productive design. Okay, and this one comes here. Okay, so we're basically done. We're done here. Okay, these guys need mirror, but just in this, the Z orientation. All right. So, and now this one, mirror, Z. Okay, so this side. Perfect. So let's say like the hardest part of the jewel is done. We just need to clean these positions. They're out a bit too much on the X position here. This guy here. And the cleaning, that's something you need to do anyway if you're using an add-on or another software. You kind of always need to clean what the software makes for you. So knowing that you need to make the cleanup anyway, you end up making certain things by hand, all right? Just like this one. Okay, so this is the main part. So now we need the body of the ring. So I'm going to use the same plain mesh. So now obviously the technique is going to be the same. So now starts a bit more. I'm done with the technical side, let's say. Now we need the body of the ring, which is a bit of a Celtic design. All right, let's make a mirror from here, okay, and here on the Z also. Okay, so I'm going to come. So it's going to be a variant, obviously, and or am I? Okay, before I do this, I'm going to call this body. Just because I need to move everything. Okay, let's work on the prongs. Okay, the prongs. Where are the prongs? They're all spheres now. Okay, sphere, all the spheres. So now I can select all the spheres with Shift. Alt C to apply the modifier, Control J. So now all the prongs are together. Yes. And we're going to move. Okay, this one is Y. I need it wider. These I'm going to make Alt C, yes, Alt C. This is all right, I guess. I'm going to, well, I can do this in edit mode. Let's hide the body for a second. I need to move everybody here to the right. So let's go to edit mode if I can. I should be able, but I need A. Okay. A. Okay, let's make it in a certain amount. Ooh. Come on. Okay, applied. Okay, this is pretty good. Let's make it a one further. And let's go to edit mode. I'm going to erase one side. And let's make the mirror again. Okay. Based on the cylinder, is it circle and Z? And why am I getting because I said Control J. Can I get okay? Everybody is fine. All right. So now I can proceed with the body of the ring. And if I need to move the setting, the pear shape setting, it will be a lot easier for the rest of the process. Obviously, you would save different stages of the design before making such applying modifiers. All right. Okay. So we're going to come somewhere here. Edit mode. Z. Now let's start. Okay, let's start here. No, these guys. Extrude. Yes. Okay, and I'm going to follow. I'm going to follow the circle, even if it's going to be a shrink wrap. It works very well because we're going to use a mirror surface shrink wrap. So this is not a big deal. And let's go all the way around. Let's overlap a bit here and here. Okay, then we'll see the shape, obviously, the rest of the design. This one is straight. And let's just have a go at the modifiers. So we have the mirror, yes, but we need the shrink wrap here to the circle. This is pretty good. Let's make the solidify modifier at 1.1, I guess. And let's go now at, well, we'll have to use the clipping. Well, not always. The clipping sometimes is not a good thing. Okay, let's do the bevel just like before. 2.2. And let's go now at the subdivision. Here we are. Level 3. Here we are. Okay, this is really smooth. And let's start making the general shape of the body. All right, edit mode. So I want a curve. Obviously, it's going to break when the distance between the vertices is too big and you're using the subdivision modifier. It obviously breaks at some point, but obviously, while moving forward in the process, everything is going to smooth out without. Okay, so here, instead of using clipping for the mirror, I like using the merge function at a certain distance, like 0.5, okay? It makes a cleaner junction between the parts of the mirror, and you have a bit more freedom making the connections. Okay, so like I was saying, it's going to break like this, or you can use it in the design, but this design has no such sharp corners. It's more like a wave or nuts type. So that comes from the subdivision modifier. Well, or the entire set of modifiers that I'm using, but that's not a problem. You just have to accept a bit of in-process breaks, like the design is going to break when you're too far apart. Like I said, if I go there, this happens. I don't want that, obviously. But even sometimes that creates some happy accidents, which are always very welcome in the design and artistic world. You know, happy accidents generally makes some of the best designs. Okay, and here we're too thin. I don't want to be thin like this. So obviously, I could make a variant with gemstones on the side. There's plenty of space on the side of the body, on the arms of the ring. But well, also generally I make designs first that are like middle cost, so people get interested, and sometimes the client says, you know what, I want more gemstones. All right, let's put more gemstones, that's no problem. Rather than the other way around of removing, having to, it's easier to add gemstones than to remove gemstones. So that's also part of the everyday life of the jewelry designer. Okay, that's pretty neat. But down there, I wanted to, let's go at bottom view. Okay, this entire zone, I want it to be butterway. I want more space here, side view. Okay, and well, this is an example. And obviously we can use, I do use a lot of curve and bevels instead of using mesh modeling and modifiers, but because generally I use the other technique, which is with the curves, I love sometimes to show that there are other possibilities. Blender has so many tools that you can always find new creative combinations. Okay, right here. So by example, like I said, now I want a small decoration on this side. So I'm going to add a Bezier curve right here. Let's go to edit mode on the Bezier curve. I'm going to remove the vertices. I'm going to turn on the drawing, the draw tool here. And the settings allow to go to the surface, and we're going to trace directly on the solid. So this is not a shrink wrap. This is a draw on surface. Yeah, this is pretty good. Obviously, I need to check the angles to follow the surface exactly. Well, if I want more precision. But yet again, this is another technique I use quite often, the draw on surface, to add some details to the jewels. And this is yet another option. Okay, so now obviously if I forgot, I want to get there. So this point is not going to be on the surface because I'm not drawing anymore, but handling the curves in Blender is always very easy, I would say. Okay, we have this. So now let's go to geometry, 85 resolution. And in jewelry, we do use some high resolution, and we don't have the same limitations. Well, obviously, when you export for 3D printing, you do want your design to be not that heavy, but then you do an optimization after designing. But first, we design at very high resolutions. Okay, I have this, and let's go to the radius at 0.5. I know, you know what? I don't want, just going to lower it, and it makes it seems like it's becoming smaller, even if it's not. So I don't even have to create any taper curve or things like that. Working with the volume generates the same look, or if really necessary, I can make the radius smaller here, but I don't even need it here. All right, great. So this is just one of my cats is just coming to join the show. This is a lot of fun. All right, okay, nice. Okay, this part needs now a mirror based on the cylinder. come on here. And let's see. Okay, so this is, and here the connection is, okay, this part got too far away. But because this needs to be at 0.5. All right. Checking that every side. Okay, this is really clean. That's what I love about the modifiers in Blender, that it makes such a clean, solid that there's not that many limitations about what we can do. All right, here. Okay, so now I'm going to copy this, Shift D, and I'm going to start making the crossings, which is part of the concept. Sometimes it's better to start from scratch, but here, because I have, well, the time is running, I just have some 10 minutes to go. So let's copy it. Okay, so now what's going to happen here? No clipping, we said. All right, great. And we're going to go on the inside. It's going to end entirely on the other side. So because I'm using the shrink wrap, I have to check that I'm over on top of the circle, because obviously otherwise my shapes are going to suffer. But first, let me move the vertices, and because it's a bit quicker to adapt the shape first, even if it won't look good at first at all. It's going to be greedy, but we'll get there. Obviously, we're going to refine this. And well, go. All right. So this is more now like a designing process, because I already explained what modifiers to use and how you can model such tools using Blender. And that's just the tip of the iceberg of all the tools that Blender has to offer. Okay, here. No, here I'm still going to come this way. All right. Let's see. Just got to learn the shortcuts, obviously, which is always a lot of fun. And okay, let's remember this one is good. All right, let's come to the center then. And all right, so the merging distance a bit less, 0.1. This is great. Okay, so this is the main, you can recognize the wavy structure here. Then it has another, well, it has many levels of arms for the ring. Okay, let's hide the gemstone for a second. All right, this is very nice. Okay, let's bring them back here. So maybe because that's pretty good. Okay, so I'm going to open now the finished model because I just have 5 minutes. Okay, so it ends this one here. Okay, so then I did also prongs for the settings for the gemstones using the same modifiers. Basically, you could do that with curves, but this ring is made entirely using the shrink wrap and solidify and bevel and subdivision. Okay, it has somewhere here the same cylinder. Yes, same technique. That helps a lot because you need to shrink wrap onto something, and because it's a ring, obviously use a cylinder. Okay, and well, then you sign. Signing is pretty easy in Blender. You just create the text, make it extruded, and make a Boolean, and that's what you get. And then let's go to the render, because obviously the render is always okay. So okay, so CycleX is amazing for the speed and also the quality of the amount of nodes and well, obviously the speed as. But this frame at 4K renders in more than 3 minutes. It's between 3 and 4 minutes, which is still very high, and I can't really optimize much more. Let me show you the stats here. Where are they here? Stats. Okay, I'm just already at 1,004,000. So it's not very low, but it's not high at all. But remember that in jewelry, all the refractions, we need a lot of light tracing here. The bounces, well, 32, and I kept low. Generally, you go at 64 or even 256 or the highest number you can in any software. And that makes the calculation in any software slower compared to other products. Jewelry rendering is always slower, just like jewelry photography. It's always very hard to make a good photograph of a jewel. Ask any photographer, professional one, they will explain to you that many photographers specialize into weddings, into pastry, into food, and some specialize in jewelry just because it's that hard. So jewelry rendering is not always very fun. It might be very frustrating, especially when you're beginning in the field. And also, that's why I recommend everybody to first become a jeweler, know about gemstone the most you can. I've taught gemology for more than a decade, so I see gemstones every day. And that's why when you're in any 3D software, when you know the gemstone in real life, you've seen diamonds, the way they shine, the way the light behaves with any gemstone, that you're able to recreate all these imperfections, because many imperfections. So now, obviously, for the dispersion in CycleX, Cycle still can't make spectral rendering or dispersion rendering, and we have to fake it. But I think my methods to create the dispersion using cycles are professionally proven now. And it's just faster than using Octane or LuxScore. Some people know that I do use Octane Blender also, which is really nice. Octane does have the dispersion calculation directly. You don't have to trick it. You can use the real numbers, the real life numbers. So that's nice, but Octane is slower, or you have to buy it. And LuxScore is amazing. So when I need the highest realism possible, as I'm using LuxScore to render the diamonds, and then, well, obviously you need to composite the diamonds in the Cycles render. So yes, again, it's slower, but it's the highest quality available using free software. The major competitor to this solution would be V-Ray, but well, I used to use V-Ray, but like 15 years ago using Studio Max. But that's another world, and I don't want to go back, honestly. I prefer all the workflow using Blender and LuxScore and Octane also sometimes. And Octane is going to get a major update, but I don't know if it's coming to Blender. I hope it will. And yeah, maybe I will buy Octane. And what else? And about the future projects, because I brought two, I used two. So these are very simple projects. These type of designs are very commercial designs that client requests and they buy my models. But I do also a lot of very advanced project that takes weeks or months to produce. This is a seahorse necklace. And so that's a lot of work because technically it's very developed. Just the chain of the necklace, it has a custom bail, a clipping bail hidden with diamonds. And on the design side, because there are many gemstones, the baguettes are technically very advanced. Some things I don't do in Blender. Obviously, many people know that. I use 3Design in my case. And then, but by example, the entire composition of the necklace is done in Blender because Blender is very fast. Now, actually, it's very fast at mesh editing. Everybody was dreaming and asking for Blender to be fast in edit mode. And I think that's something that in version 3 has gotten and is getting better, well, pretty fast. And yes, now Blender is really amazing to make all the mesh editing and make complex corrections or cleaning and addition in Blender has become a lot faster. And this is one. This one, I'm producing an animation. I made the design. The design is mine also. And there's a mask. Where's the finishing mask? My favorite. Where's my favorite? Here. Okay, so, well, now the seahorse necklace is one of my favorites. So I still have to do a lot of materials on that one. I'm just finished optimizing the scene, which is actually at 4 million. That one started at 40 million faces. Okay, this is a Venetian mask, and the inside is almost prettier than the outside, which is funny. This one is called Night and Day. You can see the night side here and the day side here. Obviously, it goes with the colors of the gemstones. This one is real scale, but I'm going to manufacture a prototype in silver at a pendant size. Well, at a pendant size. And even if I honestly almost don't manufacture jewelry anymore, maybe 10 jewels a year. So here I almost finished preparing the materials. Here on the left, we can see that this side is not clean. So the gemstones, they're inside the metal. So the shadow is grabbing the entire gemstones. So it doesn't look right. But on this side, we can see that the baguettes and the spirals, they have already the materials set, they're ready. And all the cuts are also already made. And this one is in two golds. And yeah, these jewels obviously are very time consuming on the modeling side. There's a lot of advanced booleans because there are hundreds of stones. If you look under the baguettes, every baguette has a position. And there are always technical problems because in this occasion, I can't cut the light for the gemstone, which is something that you would avoid because it makes the stone darker in real life. But I have no choice because I must keep the inside of the mask totally clean. And well, these are technical decisions you must take. And then the problem is that when you manufacture the jewel in real life, well, sometimes you need to readapt the design because in real life, you're going to see that things are not working. But when you're already in silver or in gold, and obviously it's always time consuming and very, well, money consuming because any mistake, you must start the casting again, the printing again sometimes. And, but well, it's part of the design process, and the manufacturing process sometimes needs to correct the design process afterwards. And that's how it goes back and forth and back and forth. Okay, so I don't know if there are any question.
Sorry, this is Sterling. Let me just scan. I don't think we have any questions. There's a lot of chatter in the chat group. It's mostly about some prior sessions, but what an amazing session and fantastic jewelry. Really excited that you presented this. Thank you for joining.
All right, great.
All right, fantastic. Well, Damien, thanks again for presenting with World Blender Meetup Day this year. And we've sent you an invitation to a post-event speakers and coordinators hangout. You're welcome to join or not if you're busy. That's super cool, but thank you.
Nice.
And with that, yeah, I think we'll transition to our event wrap up.
Okay, perfect. Well, thanks to you, Sterling.
Yeah, thanks to you as well.
Be fine,
All right.
everybody. Thanks. Bye-bye.
Bye-bye. So, all right, gang. So if I can get the coordinators, the World Blender Meetup Day coordinators online, that'd be great. And what I'll do is go ahead and share out this slide. So we have everybody online. So that's pretty much a wrap for World Blender Meetup Day. We hope you enjoyed it. We have a couple of closing slides just to kind of take you through. So over the course of the last 24 hours, we presented over 21 hours of content. Actually, I think it might even be a little bit longer than that. But we had 34 speakers across 26 cities and 12 countries. Really amazing turnout this year. We had over 1,627 live stream views. I looked at that like about an hour ago, so it could be actually even higher than that. So over the course of this event, we had 2,300 site visitors to worldblendermeetupday.com. A lot of people, that's where they view the stream from, so that's fantastic. We try and do some social media marketing. It's our profession, but we're getting better, I think, every year. So on Twitter, we live stream. Well, we tweeted out each presenter over the course of the day, or at least the highlights there. So if you're not with our Twitter user group, it's at Meetup Day. Definitely follow us, and you'll hear about upcoming events. On LinkedIn, we have a number of followers. On Facebook, we have a group where we post information, and we've been cross-posting information to other Blender groups on Facebook to reach about 2,300 people. And then, we have, about 750 subscribers on MailChimp, and Instagram. We have yet to get those followers, so maybe next year. But just some shout outs to the group that pulled this together. Again, they're all online here. So Andrew Buttery, running all of our Asia Pacific and kind of Southeast Asia groups. Kevin, who runs Middle East, Africa, and Europe. And then David Andrade, that handles kind of a lot of our streaming and part of North America, South America, and then myself that also manages the other half of North America, South America, and the marketing. Bart from Blender Nation actually sponsors a promoted post for our event each year, so we really thank him for that. Bart, if you're listening, we love you. Site development's done by Tanya Rogers, kind of our web mistress behind the scenes. And then special thanks out to Keith Morgan, who designed our World Blender Meetup Day logo. We really love that thing. And so, it's great to see people building real-time EV versions of that. And anything else, any other thanks, guys, before we move on? David, Kevin, Andrew?
I just want to thank all the presenters. It was a great year.
It really was, yeah, and yeah, of course, our presenters, right? This event is really driven by great content. So thank you, everybody who reached out and offered a session this year. Just shows what a fantastic Blender community there is. Kevin, did you have something to add there?
No, the same. Just thanks everyone who could make it, and yeah, had a great day.
Fantastic. And so, Andrew, do you want to make the announcement?
Yes. So, World Blender Meetup Day 2023 will be Saturday, the 18th of March. So that's the plan. So sign up now. Get in early. And hopefully we will see you all there.
Indeed. And stay in touch with us until then. And the way that you do that is one of two ways. We recommend that you, A, subscribe to our YouTube channel so you know when the event's coming next year. And number two, follow us on Twitter. So we start tweeting about a month or so before the event, and we ramp up. Those are really our two main channels. But you can also, like I said, meet us on Facebook, meet us on Instagram, meet us on LinkedIn. If you look for the hashtag WBMD for World Blender Meetup Day, you'll find us on social media, along with World Migratory Bird Day and a couple of others that happen to share our hashtag. So awesome. Any parting thoughts, Mr. David Andrade, from you?
I especially wanted to thank you guys because I unfortunately had a very tough schedule, so I couldn't contribute too much. So I thank you for setting and running the show. That was really awesome. I unfortunately have to step out as I got to pack and prep for a flight that leaves in a few hours. So thank you all for coming. Thank you all for watching. Obviously, I'll leave the streamer up until the event's all done, but thank you guys. It was really great. I can't wait to do it again next year.
Yeah, come out to the West Coast, David. West Coast, West Coast.
Working on it.
All right, Kevin, any parting thoughts from you?
Yeah, I'm just looking forward to next year already, and yeah, again had a great day.
I thought you were going to say I'm looking forward to some sleep because our World Blender Meetup Day coordinators, we none of us really sleep as we put on this event that lasts 24 hours. Great. Andrew, any parting thoughts from you?
Just once again, thank you to all the presenters and the Blender Foundation for all the support they give us each year and the effort of everybody who puts everything into Blender and makes it the amazing tool that it is. Thank you.
All right. Excellent. So just as a reminder to any of our presenters that presented this year, you should have a calendar item to come join us for a wrap party that happens after this, where you just be social and hang out and yeah, enjoy the success of a great event. But thank you for everybody that tuned in, and we will see you next year. By the way, the 4K version of this event typically goes up about a week, possibly a little bit more after the event. So stay tuned. If you tune into our social media channel, channels, you'll find out when that is. Thanks, everybody.